Commissioner, Dr. Mutambi, who would have actually loved to be here. I would like actually first of all to thank Uganda Cleaner Production Center, that's UCPC, for the collaborative support initiatives promoting the triple helix model, where this is a coordinative mechanism between government, the private sector, business contributes to programs, to new innovation, green solutions. Now the world today is faced with various challenges that are economic, social and political, and most important, environmental. Environmental challenges have been largely contributed by rapid population growth that has created demand and exerted pressure onto natural resources, be it water, land, and other basic necessities of life for human survival, such as habitats, food, etc. Now, this has pushed human beings into encroaching on natural biodiversity such as forests, wetlands, lakes. This has also led to exploitation of natural resources and converting them into high-value commodities for economic gains and day-to-day use. It's estimated today that the present population of 45 million is expected to reach 100 million by 2050. Now this implies a lot of human activity. MSMEs are the engine of growth for economic development and wealth of Uganda, accounting for 80% of the manufacturing outputs. In nominal terms, Uganda's ambitious goal to grow its economy tenfold translates in an average annual growth rate of 17% per annum over a 14-year period. Put simply, Uganda has got to double the size of her GDP every 5 years for it to reach 500 above consequences of unguided industrial processes. Our national goal defines the future we want, transforming our world reflected in our Uganda Vision 2040 agenda for sustainable development, the National Development Plan 3 problems with the same thinking we used when we created them. So now is the time for adaptation or mitigation in solutions, to global and national challenges with innovation, entrepreneurship, and globalization. Manufacturing enterprises need to control pollution, improve energy efficiency, or use alternative energy sources, minimize waste, use biodegradable waste materials, and adoption of green technologies. The ministry is involved in policies and strategies that promote SMEs to adopt green practices. Our ministry, again, with collaboration with other ministries and local governments through the district commercial officers, have been conducting training and awareness creation on policies and programs, business management, market access opportunities, standards and quality assurance. Through Uganda Cleaner Production Center, SMEs and industrialists have been trained in cleaner production and environmental friendly technologies. We advance MSME's competitiveness through establishing links with research and development agencies, academia, businesses, and other organizations committed to improving the economic situation of communities. Now, I'd like to remind you here that 22 years ago today, actually, that was about 62 years today, since the independence of Uganda, we are still lagging behind in technology transfer and development. That's 62 years from now. Imagine that. So now I urge you all, let's break through results by being courageous to the uncertainty, deepen our commitment to lifting livelihoods and ensure mutual benefits as we face common competing interests, and in any business, find opportunity and hope for a better and safer and healthier environment. So on this urge, as I conclude, I again thank the supporting partners, Uganda Cleaner Production Center, and all other stakeholders contributing to supporting this impactful environmental sustainable businesses, of course that impact that, and in developing a national circular economy roadmap that supports circular transition on the African continent. The ministry again continues to pledge support in events and workshops and programs that will help policy formulation and strategy development to play in achieving our global sustainable goals. I thank you all for listening.
Thank you so much. And I would like to welcome also those people who have just arrived. Thank you for honoring our invitations. So, very swift, we'll go to a brief introduction of what is the hackathon. And you are hearing a theme of green chemistry. What is this green chemistry? And you have heard of principles. You are seeing principles of green chemistry. What are they? And from this, we'll come to know the picture of what entails green chemistry and what are we aiming to achieve here. Because many products we aim to use in our daily life, however good they are, some of them are crippled with usage of chemicals that are not eco-friendly, processes that are also maybe energy consuming, they are not efficient. So with these different problems that are affecting the production processes, the products themselves, and also their afterlife, because our model is not only to produce and leave it there in the community, but also from the raw materials, the production process, the usage, and then the afterlife. So what does green chemistry say about all this, and what is it encouraging us as innovators, chemists? Because most people we have had here have a background of chemistry, have a background of biotechnology, biochemistry, and all that. So the essence is to bring us here to learn how we are going to address these challenges and have ideas that we can brainstorm to address the challenges that are coming with these products and their processes. So this time I'll invite my colleague Saleh to talk through the introduction to the green chemistry principles. Before we will see these people address the different issues which are brought by the challenges we called for the abstracts to address. So Saleh, it's your time.
Good morning once again. You're all most welcome. I will reintroduce myself. I'm Saleh Mohammed, Technical Officer at Uganda Cleaner Production Center. We are so very grateful that whenever we reach out to you, you are here. UCPC is forever grateful for that, and we look forward to the other calls that will come in the near future. Because ours, as you can see there, is awareness raising. You cannot raise awareness where there's no audience. And in so doing, that's how we are able to build capacity. So I'll be taking you through the introduction to green chemistry. Just an overview. Now, the era we are in today, I don't think there is something around you that has not gone through a manufacturing process. If I asked you, have you used anything which has not gone through a production process, you may not name. Everything has been processed, value has been added to it. So we cannot actually live without that. It's now inevitable to do without value-added goods. Putting that aside, as our guest of honor had pointed out here, population has increased, both globally and even nationally here. So if population increases, that's where you find pressure being put onto these industries because they have to meet the demands from the population. Industry, as we know it, comes with the consequences. With the pressure that has been applied to it, the demand it's facing, it is forced to double its production or even multiply it more times. And that brings those consequences as you can see them. That's where you find what has been contaminated because of the waste that we accumulate. As you can see, the bottles in the water, expenditure of natural resources. The very same way the guest of honor pointed it out here. The use of chemicals to maximize profits. You recently heard of a report in the news, I think it was COVID era, where these butchermen were injecting beef with formaldehyde. So you find people using chemicals to maximize profits, not knowing that they are endangering and putting risk to our human health. Accumulation of plastics, this one is not new. You're all aware about this. So those are some of the consequences that come up when industry is put on pressure. And we also have a high population growth. So when we accumulate this waste, it poses risks to the environment. And because our economy and society are both enclosed in the environment, anything that poses risk to the environment automatically poses risk to human health. That's why you need to be careful in whatever activities you do. Some of you come from industries. You find people polluting the environment, releasing effluent, which is so toxic, not knowing that that effluent is going to come back to them. So we need to take care of that. Of course, we have accumulated waste due to the high population growth. There should be waste being accumulated. And as we accumulate this waste in those decomposting sites, that's where you find methanogenesis is occurring, methane is being generated, methane which is a greenhouse gas. So all this will now impact the climate. Why do you think we are accumulating waste? Because our conventional design is more linear, where materials and energy flow in one direction, from raw material to final disposal as the industrial or municipal waste. You can see, linear. That's our today's manufacturing sector. And on top of that, we're even actually using fossil fuels more. So what should be done in our industrial processes, our process flows? We need to introduce a circular flow of materials. Because if you introduce a circular flow of materials, the element of accumulation of waste is eliminated. You don't have waste accumulating. And this idea of closing the loop of cycles of production and consumption is not new. We copy it from nature. Because in natural system, waste as we see it does not exist. One material that is discarded by an organism is used by another to grow and survive. So we copy that from the natural systems. There is no accumulation in nature. But because for us we have a linear flow of materials, we have accumulation coming up. When this waste accumulates in the environment, it poses risk. I'll say something small about these risks. A risk is simply a function of hazard and exposure. And risk is a possibility of something to happen. Yeah? Something which is actually bad. So today, where we are now, we are looking at reducing exposure mitigation. That's why you find in, some of you come from universities, schools, industries. You will never enter a laboratory without PPE. You never enter a manufacturing plant without a personal protective wear. Why do you think that is so? You're trying to control exposure. You're trying to limit exposure. Because the chemicals you're working with will end up affecting you, your health. So that's what we are doing currently. We focus on exposure mitigation. And some of us are stubborn, but we take things for granted. Somebody will go into a laboratory and a manufacturing plant without a personal protective equipment. That's possible because somebody is ignorant. Yeah? So you find that sometimes this exposure mitigation fails. So if exposure mitigation has failed, that means the risk goes high. I want you to go back to that function. Whenever you have exposure mitigation failing, the risk to your health goes high. Sorry. So if exposure mitigation has possibility of failing and increasing the risk, that means that's what we should look at. We now need to focus at reducing the hazard. Yes? Sorry? Oh. Hazards come in many forms. As you can see, some of them are human toxins, environmental toxins, physical toxins. So hazards, you're all aware about this. And by the way, in my presentation, there's nothing new. Everything you have a clue or you know. So, just a minute, let him finish so that we can continue. Okay. So, these hazards are broken down into two, majorly. Some are toxins, like the hazard is generation of adverse biological effect. You are all aware about these toxins. Some can be chemical, like cyanides, which are respiratory poisons. You have physical, the radiations. Those people who work in these nuclear power plants, they're exposed to radiation. So that poses a risk to their human health. You have biological, when you're bitten by a snake, it will put into you that venom, which is having cytotoxins and hemotoxins. Hazards can also be persistent in character. And the persistent ones are more dramatic. You've heard of persistent organic pollutants, which we are now fighting. Yeah. They are more dramatic, the DDTs, the polythene, those bottles around you. Those are the persistent hazards we have. So as I said earlier, we need now to focus on reducing the hazard. And green chemistry is here to reduce or eliminate that hazard. So that takes me to green chemistry. What is green chemistry? Green chemistry is simply the design of chemical products and processes that reduce or eliminate the use and generation of hazardous and polluting substances. That's what green chemistry is all about. And you don't need to know any new chemistry to know green chemistry. Whatever you know is enough. So what you must note in that definition is the word design. Design is intentional. You don't just wake up one day and then start designing things. No. You must be informed by the environmental challenges we have. It's intent that you have to design to address a certain challenge. And it cuts across. It doesn't matter whether it's in construction, whether it's in fashion, design, food science, design cuts across. So even what we are doing here, whoever is going to present after me, you are designers. Because design involves creativity. It's a creative process. You must be creative, and it involves critical thinking and planning to come up with innovative solutions that address our current challenges. So if you are not ready to go that extra mile, then you don't need to design anything, because you're going to create more problems. I'll have that dealing with risk. Exposure versus reduced hazard. That's what I've just been talking about. We could actually stop entering laboratories without lab coats. That's possible if we remove the hazard. But the problem is that the conventional approach we have now is reducing or minimizing exposure. Like wearing personal protective equipment, as I pointed out earlier. Yeah. But if there is no hazard in place, then exposure becomes irrelevant. Why does a chemical have to be toxic or volatile? If there is no toxins or volatile compounds in the area you're working, you don't need to have this exposure mitigation. So we need just to focus on reducing and eliminating the hazard. Now, hazard must simply be recognized as a flaw in the design process. That's why I said not everyone can be a designer. What you people are going to present after me is new designs. You have not invented anything new. You are simply trying to improve on the flaws that have happened. Because whenever a flaw happens in a design process, that's where you have these challenges come up. So you are simply going to improve on what's already existing. We need to bring a shift in our design priorities. What we have now is that people design for function. Like the water bottles you have there on your tables, a single use. After it has served its purpose, you don't know what's going to happen to it. It's going to remain in the environment. It's a persistent hazard. It's going nowhere. So whoever designed that bottle or that product had a flaw in the design. Hope you get me. Why? Because he considered design for the function. He didn't consider the afterlife of that product, the end of life. He didn't put that into consideration. So it is now on you to now come up with new designs to replace such products. So we now need to design for degradation. We also need to design for circularity. You should now, as you're designing your product, you should now consider the afterlife of that product, after use. The end of life should be considered. Only then can we now address the environmental challenges we are facing. And you cannot tell that to a businessman, of course. He will not listen to you. You don't talk things about the environment and you think they will listen. For them, they're after money. But it's now on us who are scientists. We understand this better. So it's time for change, as I've said. Because what we have now is that the bottle is fulfilling the function, the water bottle is fulfilling the function. So whoever designed that water bottle had an approach that he's going to negotiate with the risk after that. But you have seen pictures of water bottles in the ocean. So that means you have failed to mitigate that. So the water bottle has served the function, but it's finding its way in the ocean, and therefore imposing risk to the environment. So because of them, they had that reductionist approach. Fulfill the function, we shall negotiate the risk after. That's a businessman's kind of thinking. But a scientist cannot think like that. We need just to eliminate these risks. Just like nature fulfills its some of you never even know that nature is actually there. Nature will never endanger the environment. It fulfills its functions without posing imminent risk to the environment. So we need to copy from nature. I'll go to my last part, which is an overview of the 12 principles. This is the most important part of my presentation, the 12 principles of green chemistry. And for information, the presenters, in case you have any of your designs which are not addressing one of these principles, then probably the 3 million is not in your hands anymore. Sorry. Yeah? So the very first principle of green chemistry is prevent waste. That's the very first principle. It is better to prevent waste than to treat it or clean it up after it has been generated. We don't want that say of saying we shall negotiate the risk after. Don't generate the waste in the first place. And that's why cleaner production is there that's why we exist. For us, we are proactive. We don't need to hear you generating waste, then you say you are going to negotiate. How sure are we that you're going to be able to manage that waste? For us, we simply mitigate any form of waste generation. But why do you think we generate waste? Maybe most of our reactions are inefficient in those production processes of ours. So the best you can do is provide best reaction conditions for your reactions, maybe to improve the efficiency of reaction. They're designed to avoid purification. These organic synthesis chemists, I was once in a class of polyfunctional, I think a practical. You have, the whole practical is full of just purification. Yeah? You're trying to prove, after synthesizing the product, it's just, the next steps is just purifying, literally. Yeah. So that just shows that that synthesis is wasteful. The impurities you're trying to remove from your desired product are the ones forming undesired product is very low. It has a high selectivity rather. So we need to use such least wasteful materials. I'll give an example of that prevent waste. This is a pharmaceutical product, sertraline, an antidepressant of serotonin. So in this manufacture, as you can see, please don't switch off. You know, when people start seeing the rings, they just close. I'm not here to teach organic chemistry, but one organic chemist follows that whole route to produce that very sertraline. Another person can do it in one step. That's the funny thing about this organic synthesis. And for the small organic chemistry, you know, unless the reaction is an addition reaction, most organic has prevented accumulation of too much waste. We will not say he's so clean. He will also give a minor product. Just that this minor product, the quantity may not be the same as the other person who has followed that whole longer route. And to a businessman, the cost-effective way is to use the shorter route. So why would you go all that far? The second principle of green chemistry is maximizing atom economy. Green chemistry goes ahead to prevent waste at atomic level. You can see those two examples. All the reactants are going into the product. You don't have any minor products forming, because the minor products are the ones that are going to come into waste. The example is those two, production of ethanol. You have fermentation of glucose and reaction with ethene, hydrating ethene to get ethanol. The second reaction has a higher OM, has a maximum atomic, has an atomic economy of 100%. So a green chemist would actually choose this second reaction because it's least wasteful. Of course, atomic economy is simply the mass of the product over the mass of the reactants that are forming it. That's how we get that percentage. So we need to use those reactions that maximize atomic economy. Because if a reaction is maximizing atomic economy, that means it's least wasteful. Less hazardous synthesis. There are many rings here in organic, like in green chemistry, because really it refers to this. So don't run away. But we need to use less harmful or innocuous chemicals in our synthesis. Like that one is phosgene. This is the gas which was used in World War I. Yeah? It is actually a respiratory danger or hazard. So can you really work in such an environment? No. You need to now substitute that phosgene with much safer chemicals, dimethyl carbonate, to produce the ureas and the carbamates that have use, of course. So you need to replace this phosgene, which is dangerous, with least harmful reactants, like dimethyl carbonate. That's an example of a less hazardous synthesis. We need to design our chemicals to be safe. You've heard of PCBs, they're also POPs. These PCBs, some of them are even unintentionally produced. You find them their way to our aquatic system. That's how you eat fish. Some of you are very good eaters of fish. You eat fish, then you find yourself accumulating all these chemicals in your body. So we need to design chemicals that are safe. Because these PCBs are used in those transformers. You don't know how it can even get into your food. Yeah. I think some of you are now happy. That's what some of you are addressing. Those who are addressing the challenge of VOCs, volatile organic compounds in the paint industry. We need to design our solvents and auxiliary chemicals to be safe. That word benign means safe. Yeah. We are now shifting, for those in the paint industry, we need a shift from those white spirits of yours to water-based paint. That's what we want. That's what green chemistry wants. That's what green chemistry challenges you. Because whoever designed that paint to have a solvent as a white spirit had a flaw in the design. Because the white spirits are those are sources or are very good emitters of volatile organic compounds. And actually, on the very point of solvents, you are all aware that our industrial processes occur in a medium of solvent. We need solvents. So if we can't remove the solvents, we need to replace them with safer solvents. You can't say you're going to remove something or phase it out when you don't have a suitable alternative. No one is going to listen to you. So you need to design safer solvents. Design for energy efficiency. That's the sixth principle. You need to design your reactions to be efficient so that they occur at ambient temperature. If your reaction is occurring at ambient temperature and pressure, you don't need to add in or input energy. It does not call for that. So that's what we need to design our reactions to be. The seventh principle is the use of renewable feedstocks. We are running away from oil and gas, of course. We can't be reliable. It's not reliable. Because oil is one day going to get extinct. That one is no doubt. It's going to happen. Maybe tomorrow, 10 years from now, 1,000 years from now. One day, those oil reserves are going to dry out. Then where are you going to run to? So as we talk right now, we need to be using that oil and gas. Yes, we need it actually. Oil and gas is a very big industry. Actually, almost all industries, almost all of them, depend on that oil and gas industry. Almost all of them. Actually, if that industry was to fail, most of these industries are going to run out of business because they depend on it for the feedstocks. So as we're using oil and gas, we need to be building capacity in the use of renewable feedstocks. The challenge we have with these renewable feedstocks that most of the biomass, you need very many quantities or too much quantities of this to get just so little. That's the problem with this, and these natural products people are very well aware about this. You need to have very much vegetation to get just small amount of the extract. That's the only challenge we are still having. So we need to optimize those processes so that we quantify and know how we can better extract whatever we need from these renewable feedstocks. So that's the capacity I'm talking about. Intensive research is occurring in that field of renewable energy and renewable feedstocks. So we need to build capacity. We need to run away from use of, as you can see here, minerals. You have heard of this company, Kasese Cobalt. It's no longer running. It is extinct. Why? Because its feedstock is no longer in place. You can go there, it's just seated there. It's now a tourist attraction. Students of industrial chemistry, I think, go there. Principle number 8 is we need to reduce derivatives. Organic chemists will be happy here. Sometimes you have a polyfunctional compound with two functional groups. Yeah? But you need to get this product. So it will force you to mask or protect one of the functional groups. Because if you don't, this is what you end up with. So somebody will now protect that by using a derivative or a protective group so that you now end up with the product you need. But this whole process, the deprotection, will now give off waste. Because after you've used this protecting group, it's going to now become waste. So we need to really reduce on the use of those derivatives. Principle number 9 is catalysis. You're all aware about this. We need to run reactions that are more catalytic in nature. You can run a catalyst on many cycles. You need to run it from use of stoichiometric reagents. We need to design for degradation. I already hinted on this. Some people will present bioplastics here, you'll hear. That's what we want to hear. We don't want to come up with these plastics which are not going anywhere. The 11th principle out of 12, I'm about to finish, is the real-time analysis. If you've ever been to these manufacturing plants, you'll find that they have control rooms in place. Some people actually pay to sit and look at those screens 24/7. You sit just looking at the screen. There's a reason as well you're paid for that. If you've ever done process control, there's what we call feed-forward control. You don't want a disturbance to come into your process. You need to be monitoring the process from the start to finish. Otherwise, if you leave it to occur unmonitored, that's where you find that things go wrong. Yeah, like you're cooking food. If you have dedicated yourself to cook food in the kitchen, you need to be present. You're not going to get things that just put in a saucepan and then leave. Otherwise, you're going to end up burning the food and wasting it. Or you're going to waste energy. You need to be present. That's what the real-time analysis is all about. You need to be there to monitor that process occurring so that you don't have any waste or things going wrong. The last principle is that you need to design to prevent accidents. You've been to industries, you move, but you feel anything, it's a time bomb. Anything can happen in that industry, anything, at any point in time. But if we design safer chemicals, which we are sure of, then you don't need to be in fear or in shock. This example it was in Bhopal, India, where this pesticide industry manufacturing this insecticide, carbaryl. One of the reactants in that reaction is 1-naphthol and methyl isocyanate. This one. It's a very dangerous chemical. So we find that people who were exposed to it, most of them died. But if we have somebody who can replace this dangerous chemical, then such things cannot happen. So that's the 12th principle, and I'm now done. I'll leave you with this quote that from Chief Seattle. We do not inherit the earth from our ancestors. We borrow it from our children. And if you borrow something, you ought to return it. Some of you are fond of borrowing things, borrow this, borrow that, and you don't want to return. So this very planet we are in, you've borrowed from your children. So you need to return it to the children. And that's the sustainability we talk about. I'll stop there. Thank you so much.
Thank you, Saleh, for taking us through chemistry. Some of us who had forgotten it, thank you for that. And if you have checked our schedule of activities, we are late by around 9 minutes. So we are going to have a working break. So we'll have our team to serve first. And the working break, I mean, as we're preparing to start with the presentations after that break. So it will be around 15 minutes. So we'll have our panel to receive first break. People are already waiting for us. And as here, we'll have brief interviews here. Short interviews. So don't fear that they are very, very hard questions. No more questions. So here, as the line decreases, you switch, have break, and then we'll be preparing for our next session. Thank you. Hello, hello, awulira. Hello. Hello, hello. Oh. So speaking about, I'm sorry about that. So the main challenge which we are going to talk about in this first segment of our program is going to come from, as I highlighted before, from the leather industry. And it's about solid waste management in tanneries, whereby we are seeing approximately 70 to 80% of the inputs in the leather industry become waste. So with different ideas that are coming to come address that solution, it may be about reusing, recycling, because at this time we are aiming or targeting towards the waste side, because the product we said it will be about 30 to 20% as we if you calculate the remaining of the waste. So we are trying to address this issue because from an investment point of view, an investor would not want to invest a huge amount of money and you tell them that 80% of their investment is going to waste. That will not be a sound investment. So with these ideas on board, it will give the investors leverage and confidence to also see that they can invest more in the leather industry. And we are seeing that we have solid waste as hide trimmings, fleshings, the sludge containing the chemicals, and the liquid part of the waste. Many solutions out there address it, and for it can be processed to other dedicated solutions. But the solid waste is the one which has a lot of issues here and there. And at the rate we have said 80%, if you're having a ton, that's almost 800 kilograms. So that waste will really escalate. So, and then what we are looking at here, to develop innovative methods to reduce, recycle, upscale the tannery solid waste while minimizing the environmental harm and aligning with the green chemistry principles, which Saleh did a good part of addressing here. So we are going to start with applicants who had sent in their abstracts for the presentation addressing, and we are going to start with Daniel and Fiona. It's your time. So they will come and talk more about their solution. So it's your time, Daniel and Fiona. And as they prepare, we should all know that every participant or presentation will be 10 minutes. And then the segment of 5 minutes will be to the jury to talk more, to ask more questions, and to seek clarity. So we should keep that in mind. Can we hear from the judges online before we start? Like a brief introduction.
Yes, hello. I'm Thomas. Can you hear me? Good morning.
Hello, Thomas.
Yes, hello. Hello, hello.
Hello.
Hello. Posso
before treatment, after the initial cleaning, we shall go straight to hydrolysis. Hydrolysis of the what? Of the raw, the waste, whereby we shall first of all redo size reduction. After doing size reduction, then we shall employ an enzyme called collagenase. This collagenase enzyme acts on the collagen in the skin or in the hides. So when this collagen reacts, it will break down this collagen or these wastes into amino acids, essential amino acids for livestock and poultry production and health. When we are handling products or offcuts from treated leather, we tend to do detanning and also neutralization, whereby we shall employ some chemicals, some reagents to reduce chromium from chromium 6 to chromium 3, which will be turned into soluble solids that can be precipitated out and also filtered, so that we get rid of the chromium. Here we shall employ HCl and sodium hydroxide. HCl is basically for reducing chromium 6 to chromium 3 and also turning it into soluble salt chlorium chloride. That chlorium chloride can be solubilized and precipitated and filtered out of the waste. Then we shall have to neutralize the HCl, because we remember we are using an acid. We shall neutralize using sodium hydroxide. That's when we are handling or we are working on products, wastes from the already tanned leather or hide. I talked about hydrolysis, but hydrolysis, this one can be done on both. The other one, which we directly cleaned, the fresh one before treatment, and also this one that has been treated or detanned by removing the heavy metals. After hydrolysis, we shall do drying the collagen. The processed product. So we shall dry. After drying, we shall have to grind, or we can do the pellet. Now this pellet is for easy, because we are preparing a concentrate from this waste. So after drying, we can either grind or we can form pellets. Now these pellets can be mixed with other ingredients to form an animal feed. In terms of quality control, we shall set a system to ensure there is consistency and also safety, because during preparation or processing, we need to follow steps and we need to comply with good manufacturing processes and practices. Then in quality control, we shall ensure that we do nutrient testing to ensure that the product contains the essential amino acids in the required amounts, so that they are we ensure they are nutritive, and before we release them to our maybe the potential clients, they are ready and of good quality. Then we shall ensure safety testing. We shall test for the presence or removal of heavy metals, from complete elimination of heavy metals from the product. And also we shall do microbial testing. We shall focus on Salmonella and also E. coli. Then the other test that we are likely to do is aflatoxins. You know, aflatoxins have become a problem these days, and once they get into the food chain, they affect everyone. When we look at market potential, it's projected by 2030, products manufactured from leather wastes, it's projected that it could capture animal feed market by approximately 5%. That is estimated at $5 to $25 billion. And the market potential, given the fact that Uganda is an agricultural country, we see so many farmers around. So we look at capturing market from poultry farmers, livestock farmers, fisheries, and also other these people who make formulation for pets. Competitive advantage of this product, it's a sustainable solution whereby we shall be having access to cheap and readily available raw material from the tanneries, and it's a cost-effective approach to managing and also coming up with a less cost animal product. And we estimated that having locally made product from within our country, we could cut costs of importing, because most of these concentrates are imported from abroad. So when we manufacture or make our product from within, we shall have cut the costs. And when we look at nutritional value, this hide comprises of about 33% of protein. So it is a very rich source of protein. Being an animal protein, it could be of value to our clients. We shall be supporting circular economy whereby the waste is easily turned into a valuable product. Our business model, we focus on, we have a waste to feed concentrate model, whereby from the waste we shall develop or process into a valuable product, and this product shall fetch revenue in terms of sales to our clients, and also as well as partnering with tanneries. Yeah, they could give us some small fee of like managing their waste. Go-to-market strategy, we shall do market research, shall look around and map out our potential clients so that we are able to do business with them. And also we intend to promote sustainability, whereby we shall comply with the circular economy practices and principles. Then we expect to do or make partnerships with key players in the industry. Sales strategy, we shall employ or partner with expertise in the marketing field to do for us the marketing, and we shall also be present to support them. When we look at the impact of this project, especially in terms of environment, we shall have saved the environment from pollution by the wastes, and also in terms of economic impact, we shall have principles and practices. Thank you for listening.
We are so sorry about what had happened. The first hiccup of take, but now at least we have stabilized. We are sorry for that hiccup. And we will now hear from the panel of judges if there are any questions, the clarification or inquiries. Any?
Thank you, Waiso and team. Just to clarify, the 75%, is that what is not used or what is converted?
The 75% is the one that is unutilized.
So they are only, the conversion rate is 25%.
Approximately 25%.
Okay, so now just to now, if you're solving a problem and people are only converting 25%, it means logically they're not in business. They are total failure in production dynamics, complete failure. Because if I put in this and I'm only going to convert 25, I should quit, I should stop. Now, if you tell me you're going to manage my waste, and then you mention profit maximization, on whose side, you need to clarify. On me as a turner or you as a buyer of my 75%. We need to see solutions addressing societal problems for them before we think about what we want to do for ourselves. So that's why I have a big problem there. Where 75% is for the turner is not converted, and only 25 is converted. We need to look at that. Then another thing, the chemicals, you're using chemical methods to recycle the 75%. We need to be sure about
turn into leather. So that's inevitable, that's the eggshell. So however much you optimize the turning process, we cannot optimize the eggshell unless we can engineer chickens or cows that cannot have freshings. So they cannot address that problem. But what they can address is to give us solutions on how they can use the eggshell. Now those are the offcuts and the splits. Now they're trying to give us solutions to produce. So you may not answer that question of optimizing the leather sector. But now you tell us other questions, how you're going to address it and how you are using they are. Okay. Maybe I have set grounds for that so that you don't go into optimizing the leather turning process.
Okay. Thank you so much, Edson. Yes, he has really clarified a very important point. Okay, so you mentioned something about chemicals producing more chemicals. So our process is not, we're not using any chemicals. The only part, if you go to, I don't know if you can all see, but if you go to the technology overview, so firstly we are cleaning the waste. After that we are detanning. So the detanning part is where we remove chromium, right? So in there is the only part where we're using chemical. We're trying to remove the chromium from the waste so that we can then convert it into animal feed. Right after the detanning process is when we have hydrolysis. So hydrolysis, our hydrolysis process is going to be using enzymes. They are not chemicals. So that's why we're not adding any chemicals. We're not increasing pollution again. I don't know if I've clarified. Yes. Is there any other thing I've not answered?
Yes. Can I pick it up from there?
Yes, please.
Thank you very much, Daniel and Fiona, for that interesting presentation. I'm sorry I came in a bit late. My name is John Waswa from the Department of Chemistry, Makerere University. I'll pick it from the chemistry perspective. You talked of reducing chromium-6 to chromium-3 and eventually converting it to chromium hydroxide, which is a chemical. My concern is, what are you going to do with the chromium hydroxide after you've converted it to chromium hydroxide? That's one. Two, in your process, you are talking of hydrolysis. The little chemistry I know is that hydrolysis involves reaction with water. That's why it is hydrolysis. But now you are talking of an enzyme. Can you please clarify to the panel what exactly is going to happen during hydrolysis? And finally, the third question is the nutritional value of the feed you are producing. Have you been in touch with the nutritionist to assess the nutritional value of the feed, the potential feed that we are going to produce. Maybe you are going to create a problem from the problem we are solving. Thank you very much.
Okay. Thank you so much. Can I kindly request Samuel to help us, because we can't navigate the PowerPoint from here. Just okay. So let's go to
Yeah, thank you so much for those questions. That shows that everyone is very attentive and and is really dedicated. You all dedicated to coming up with solutions to these challenges. Yeah, let's go back to the nutrient composition of the hide. According to literature, we have 33% containing of the hide contains protein. And when we go through processing, we lose some of them, of course, as we process. But at the end, this is where we talked about quality control, whereby we shall test the product at the end of the day to ensure this product contains the nutritional requirements, the essential amino acids required by the animals or the livestock. So we shall have to test this product before taking it outside there for marketing. Then we shall also test for safety, testing for residues of heavy metals and also other contaminants like aflatoxins and some microorganisms, looking at salmonella and also E. coli. He talked about chromium hydroxide, which can be precipitated out. You can do further treatment and recover the chromium from the byproduct and use it for other downstream processes. Hydrolysis, in this reaction we shall have collagen, that's the hide, and the water. But the enzyme collagenase will just act as a catalyst to break down the collagen into amino acids. You know, this, we can't do it at once. This will be a process. We can do trials and do optimization. So once we find out that there is aflatoxin, of course, we shall not take that one to market. Then we shall also have to train the handlers right from the raw materials, where we shall be picking the materials to avoid contamination. You know, aflatoxins, it's a fungi that grows, it's aspergillus that grows and produces the toxins called aflatoxins. So through quality assurance, we shall ensure we source materials from clean and well-trained handlers so that we are able to go through the entire process. And we talked about complying with the good manufacturing practices. So we shall ensure quality assurance is in place by setting a system to make a follow-up on consistency and ensure that there is no contamination at any stage. So when we come up with a product and it contains maybe aflatoxins or it contains the heavy metal, we shall have to check the process and do a corrective action. Thank you.
Also, to answer a question the Assistant Commissioner had asked, he asked about waste. You said that as we continue to process the waste from the leather tanneries, probably eventually there'll be no more waste. So we will not have what to use, but we can still use the cow hides as is. We can use them, we can get them from the abattoirs and still use them to create a concentrate. Yes.
Then also, to add on that, I think we shall not run short of these raw materials because the tanneries are there to stay. Because we need these leather products, okay? So, and as Edison highlighted, it is inevitable to have the 75%. So I think we shall still have the waste from the tanneries to make a product. And I don't think this solution is short term. It's long term because we still have the livestock sector. We have the poultry, which is a growing industry. We have fisheries, people who are keeping fish, and even livestock. We have pigs, sorry for my Muslim brothers and sisters, but that pig industry is also a growing industry, so we expect to have the market, and it is a long-lasting solution. As they generate the waste, we shall have the raw material to also push it to the agriculture sector. Thank you.
Water, how do you treat? You said it's cleaning or something like that. You use water?
Yes.
Maybe my concern still goes the same, like it's waste management. Have you established how much waste will be generated out of this process, approximately? And how are you planning to go about the treatment, or what's the plan with the waste that you'll be generating?
So the first part is
Thank you so much for that question. The initial cleaning, we shall use water to remove that, dust and other foreign materials. Foreign materials can be sorted out. Could be plastic, could be metals, could be anything. Then about the waste that could be generated through the process, we shall do further analysis on that and come up with the estimated waste that can be generated out of that. But we expect to have very little out of it. The water, of course, we shall not just discharge it to the environment. We shall ensure we work in a closed like system, so that whatever we generate can't be just released into the environment, because that's what we are trying to fight. Because we expect to establish a facility that we shall use to handle and manage all the entire processes.
I think it's very good. I just have to let you know that I see it's gender balance, but remember to qualify for the raw project, the lady should get over 50% of the shares.
Thank you so much.
Thank you very much, Daniel and Fiona. I have just two questions. One is on the enzyme. Are you manufacturing the enzyme yourself? Where is the source? And how costly is it? Is it affordable?
Thank you so much, sir. We are not manufacturing the enzymes, but these enzymes are on market. Commercial enzymes are on market, and the cost of the enzymes collagenase, 25 kilograms go for 440, but we use very little. For a kilogram of the hide, we may need like 0.1 gram to react with a kilogram of.
Okay. The other question is on the HCl. Eh? Couldn't you think of a substitution of any other acid to substitute the HCl for purposes of, one of the principles was produce something that is biodegradable or easily degradable. But now you have this HCl. Can't you think of a substitution, another acid, that when even after the residues, you can have it degraded? Thank you.
Thank you so much. We shall also explore various alternatives and substitutes so that we have it done very well.
Can we give them a hand of applause? Thomas, do you have any comment, any inquiry before we proceed?
All my questions were already asked from the panel, actually. So everything fine.
Oh, that's good. All the questions have been answered. All questions have been answered. So we are going to go for the next team, because the first one had issues with tech and all that, but this one will be swift. 10 minutes, 5 for the judges, then we shift to another one because we have a lineup coming. So this time I would like to invite la team for the next presentation. Thank you. Just press this.
Protocol observed. I greet you all. My name is Latim, Timothy Lagambe. I'm a graduate from Makerere University. I've just completed my undergraduate studies in industrial chemistry. I'm here in response to the challenge to develop innovative solutions for the effective reuse of solid waste from tanneries, particularly focusing on leather pale trimmings. Here with me, I have a presentation to repurpose tannery waste. It's evident that leather is a very important, leather industry is a very important industry in our lives. And with the ever-increasing population, the demand is also ever-increasing. So, like the previous speakers had hinted, almost 75% of the inputs in the leather industry are given out as waste. And as scientists, we all know there are some terms that move hand in hand. When you mention waste, there are other terms that follow. There's pollution, toxicity, disposal. And with the ever-increasing demand for the leather products that are coming with the increasing population, the waste is also going to keep on increasing. So there are always questions that are going to come up. How are we handling this waste? Where are we going to dispose this waste? So with this, there are a few environmental problems. Focusing on toxicity, the heavy metals, especially chromium-6, the hexavalency, it's highly toxic, carcinogenic, also mutagenic, therefore posing a big threat to human health and ecological health. All these are challenges. Of course, when they are producing them, the companies will say we shall dispose them well, we are abiding by the environmental standards. But I would want, I was saying, yes, we are going to be using it to produce fertilizers, which is an indispensable product in the world, especially for developing countries like we ourselves that use agriculture as a major source of revenue. With this innovation, there are a few value propositions. it's environmentally sustainable in that there will be reduced landfill use, incineration, and associated pollution. Then another benefit are the economic benefits. It's cost effective to produce the fertilizers because the input is waste. So the cost of inputs will be reduced since it's a waste from another process. Then it promotes a circular economy in that it promotes reuse and repurposing of waste. Then it also creates more economic opportunities and introduces the dependency on synthetic fertilizers. Another one is savings incurred in waste management. This is a win-win solution in that the leather industry will be saving on waste, on the costs incurred in waste, in that instead of paying other institutions to come and manage the waste, they'll be repurposing it. And the fertilizer that will be produced will be sold. So it's a win-win. You're saving on waste and you're getting more revenue from the fertilizers. Then it supports sustainable agriculture. Since there's an increasing demand for organic foods, and this is an organic fertilizer, therefore increasing its market. I'm going to run you through a brief summarized technological overview. So where the waste is generated from the leather industry and we receive it, or maybe within the leather industry as well, because the leather industry can be the one to manufacture the fertilizers as a byproduct. Then, the first process will be pre-treatment, the waste. It contains heavy metals like the alkaline, like the chromium, cadmium, lead. So we precipitate this using alkaline solutions, and then this is separated. Then the remainder, which is the cut-offs and the shreddings, are sliced and washed.
I thought you know the people that are talking about.
From the separation, we shall continue with the wastes. The washed cuttings and shredded ones. So we shall go to the hydrolysis. In the hydrolysis step, we are hydrolyzing the proteins that are present in the waste to form peptides and amino acids. This will be the source of nitrogen in the fertilizer. This can be done for about 6 to 12 hours and at a temperature of about 80 to 100 degrees. These parameters vary depending on the temperature and the concentration of the acid that will be used. And from that step, we shall go to the neutralization and stabilization process. In this process, since we have used hydrochloric acid, phosphoric acid to hydrolyze, the solution is still acidic, so we need to neutralize it. Here we shall use slaked lime, calcium hydroxide, and with basic chemistry we know bases react with acids to form a salt and water. So here the slaked lime will react with the phosphoric acid to produce calcium phosphate and water. And the calcium phosphate here will be the source of the phosphorus in the fertilizer, and calcium being the micronutrient. Then, after this step, we shall go to the fertilizer formulation. This will depend on the consumer requirements, consumer needs or demand. If they need the fertilizers in liquid form, we filter it, remove the solids, then packaging. It will be containing nitrogen and phosphorus, then the calcium as the micronutrient. Then, if they need them in solid form, we dry it to form pellets or powder, then package. Then if the consumer need it in NPK form, that's nitrogen, phosphorus, and potassium, we can add potassium salts according to the demand. So the process is adjustable. That's the brief summary of the process, the technological overview. And this would be the expected composition, about 6 to 12% nitrogen, 5 to 10% phosphates, and 40 to 50% organic matter. I read an article earlier Similar research was done in China. An article was published in 2013 by the National Engineering Lab for Clean Technology. Research was done solving the same problem, but here they used aerobic fermentation. And their percentage compositions weren't far below this. And this being a more efficient process, I believe the compositions can be met. This is a summarized, this is an illustration of the block flow diagram of the process. Market opportunities for the fertilizer. There's increasing concern for the deteriorating fertility of soils. Just last week on NTV I was watching, I think a body under Narrow was in Sorotic, and the residents are complaining about the levels of their fertility they don't have food. They are calling on to the government to help them. But this is one of the solutions. It could be a very good solution to their problem. Growing demand for sustainable fertilizers. This fertilizer is organic, and it doesn't use synthetic wastes. I mean, doesn't use synthetic ingredients, unlike the current fertilizers in the market. The global food market, this is the increasing demand for global demand for fertilizers. The global food market is expanding rapidly, creating demand for organic and eco-friendly fertilizers. And it's an eco-friendly product in that it provides long-term fertility to the soils, unless some of the synthetic products, I mean fertilizers that we have in place, that need constant application. Every planting season you have to keep on applying. In that here you have to apply in lesser intervals, bigger intervals. Market size projections. The sustainable fertilizer market is expected to grow at a compounded annual growth rate of 12% till 2032, driven by the growing adoption of organic farming and rising environmental awareness of the fertilizers. And this fertilizer, aligning with these trends, falls within this category. What are the competitive advantages of this fertilizer? This fertilizer, there's reduced chemical residues in the environment, unlike synthetic fertilizers. Then, in this process, there's low energy used for production as compared to the synthetic fertilizers. I think the only energy input would be in the temperature, which is not very high. That was about 80 to 100 degrees Celsius, depending on the concentration of the acid. Then these fertilizers align with the global shift towards organic and sustainable farming. Then lastly, ternary-based fertilizers can enhance growth of useful microbes in the environment, which fosters a healthier and more productive ecosystem compared to chemical fertilizers. These ones, the chemical fertilizers just come and add the nutrients, like NPK, it will come with this nitrogen and the micronutrients. But this one, first of all, part of the raw materials being organic, they already contain microbes. So it enhances their growth in the environment. There are a few challenges that come along with this process. Like I remember I said, in the technological overview during the pre-treatment, the chromium is precipitated and separated from the leather. So there's a possible challenge of chromium contamination. Then since I said for the hydrolysis, we use phosphoric acid as a catalyst, there is a risk of corrosion on the equipment we shall use. Then also during hydrolysis, there is a risk of odor, bad odor from the proteins. Well, here are a few solutions to the problems. For the chromium can be used as an input into other processes. As you know, chromium is a metal. It can be applied in the metallurgical industry in the production of alloys, since it's among the products, it's among the inputs in the production of stainless steel. Chromium being a transition metal can be used in the pigment and dye industry to produce multiple colors. For example, chromium green and it can also be used as an input in the ceramics industry. Then for the corrosion, which is a problem from the acid, we can use corrosive resistant equipment. Then for the odor, we can solve that using biofiltration systems or addition of odor neutralizing agents like zeolites. Well, with this, I believe this is a sustainable project, and quoting what my colleague here said earlier about the green chemistry, I think I fall within about 6 of them. So this is a good project in my opinion. Thank you. Any questions?
It's the jury's time for any inquiries, questions, compliments, and all that. Thank you.
Thank you for the presentation. Let me go straight to sustainability. I'll get it from towards the end when you're talking of the 3.
We are going to give those who have questions now, and we note he answers all of them. In that, it will be swifter. So everyone, as he notes. Thank you.
So simply you are saying I don't expect the answer now. Okay, addressing the issue, thank you for trying to get a solution. But I'm looking at sustainability, and if I look at your process, the production cost versus the cost of removing the contamination, the 3 aspects, the chromium, the odor, and the other third one, I don't remember very well. In your presentation, I don't see an overview. You know, following what the first people presented, that give us an indicative cost of production and the cost-benefit analysis. In your presentation, I don't. If I look at the cost of addressing the issue of chromium, addressing the issue of odor, in your own perspective, can you give a reflective performance of your cost of production against working against these other environmental effects, which could be detrimental to sustainability?
Yes, Latin, thank you for the presentation. I think one of my concerns has been raised by my colleague, but I will also raise it again for purposes of emphasis. First of all, are you a team or you are an individual?
I'm here as an individual.
Okay. Okay. Secondly, you are precipitating out the chromium into a precipitate. How do you intend to handle the precipitate? How do you intend to handle the precipitate? Secondly, you convinced us that your fertilizer does not use synthetic chemicals, but at one stage you intend to introduce potassium if they want the NPK fertilizer. So how are you going to introduce the potassium without using synthetic chemicals? And lastly, you talked of using corrosive resistance equipment to solve the problem of corrosivity. Like what equipment? You didn't tell us. The equipment you intend to use, that is corrosive resistance. Thank you.
Thank you, Timothy. Most of my concerns, I think, have been touched. However, you gave us some statistics on the nutrients. Where do you get this data? Have you done the preliminary tests? Have you done some preliminary tests? Because Because where do you get this piece of data?
Thank you very much, the team. Now, the first question also goes to the previous team. Presently in Uganda, what happens to that 75%? Maybe you will answer for them because you are in the same area. What happens, exactly what happens? Are you the first ones coming up with these solutions, produce feeds, to produce fertilizers? That's one. Secondly, the biggest challenge we have with innovators in Uganda, I'm now speaking on behalf of the Science, Technology and Innovation Secretariat Office of the President, is innovators, people go assume problems and therefore assume solutions, and then they cannot be taken by the general populace. Now, my question is, have you had any discussions with the potential off-takers of your offering? The same goes to the previous team. Answer it secretly there. Any discussions with potential off-takers? Oh, you want to, we visited an agricultural farm. They had designed a machine, and they were like, hey, we've taken this to people, but they are rejecting it. They should, because who told you it is they want it? So innovation should be centered to problems which actually are experienced by the general populace, not because you think it's a solution to someone's problem. That's where we get challenges, that things are not going, STI is not giving us money, because you're just telling them your thoughts, not the thoughts of the recipients, those who are going to receive your solution. Thank you.
Yeah, that's a very good presentation with that question. I just have one question. You repurpose and they make animal feeds. I don't know which would be better. Now, can you take their waste instead? Can you work with them? And because they said if more than 50, if the aflatoxin content on their waste is beyond, they didn't actually say what they would do with that waste. But can you take it and repurpose it?
Thank you, Timothy. My only maybe concern at this moment is when you mentioned about the solutions to the problems that you think you'll encounter. One of them was the management of chrome. Management of chrome. You talked of chromium? Yes, chromium. And you mentioned that it can be used in pigments and dyes. I'm from the coatings industry, and for us it's a no. Pigments that contain chromes, we don't need them now. So, sorry. Yes. Even in EMA, we will not accept. Thank you.
Thank you.
Yeah, thank you very much for some questions. I think some of the questions posed to the team, they are high-level questions, and I would like to talk to some of the questions. The first question was concerning off-takers and the current status in the leather sector. I need to talk to that. So it's UCPC who identified these problems. We went out to industries and asked them, what is the problem? For example, in the leather sector, actually, out of like 5 leather factories in Uganda, we have like 2 that are actually processing now. Why? Because of things that happen globally. Chinese couldn't export leather to USA, and the demand for leather domestically fell. Leather industry that were not innovative, they had to shut down because it's only about 25% that ends up as a product. It's only one leather factory that was innovative, that repurposed its waste, and it's only working because it repurposed its waste to production of gelatin. It had an alternative revenue stream. So other leather sectors that didn't innovate, they had to close down or they have to operate at a loss. For example, Elgon, I don't know if it still exists. Novert produces once a month. Leather industry of Uganda, does it still function? Now, it's only Skyfat. But because it managed to repurpose waste, so had to go back and talk to them, why are you not operating? So they gave us their problem, that this is the challenge, the money is small. So we try to seek and come up with other revenue streams. Because leather itself is a waste from the beef industry. Now the one who was trying to address the problem of the waste from the beef industry is being affected by the global geopolitics. So now that's why we are coming up with local solutions to create new revenue streams to the current problem. For example, Skyfat invested about 11 million US dollars to address the waste challenge, but now it's still operating. So I think you don't have to talk to that problem. Two, we talked about if they're in contact with off-takers. Actually, the whole program is about linking these innovators to off-takers. And tomorrow shall be officially launching. This is just like a teaser. We want to launch a bigger Greenchem Innovation Network Program, accelerator, for the next 3 years, where we shall be able to see such talents, mentor, do business coaching, avail seed capital, and then also introduce them to investors. But we have to talk to industries. For example, Chris is not coming today. He's from Skyfat. They are ready to give us their laboratory, shared laboratories, for these people to pilot their solutions. And then we see how we could scale them up. Because for them, they've already realized the benefits of innovative. They've realized the benefits of green chemistry. Chris was operated, they are telling us how they have benefited from that. I think the difficult questions are for you. I've answered it.
Thank you, Edson, for the assistance. Well, thank you for your questions as well, my dear judges. They are eye-opening. Starting with what I... Oh yes, starting with how I handle the precipitate. Like I said, from the precipitate, we are precipitating out the heavy metals, like chromium being the main ingredient in the precipitate, and that's what that was the main ingredient, and I addressed it later in the harm solving the chromium generation problem. I hope I've answered your question of harm handling the precipitate. Then I was educated about chromium not being used in the pigments and dyes industry anymore. Well, among my solutions, I think there were about 3. I think maybe we want to use them in the pigments and dyes, but you can apply them in the ceramics industry and also in the metallurgy industry, in the production of stainless steel, where it's a raw material. Then you said if I could take the waste of the people who spoke earlier. I think there was a misunderstanding. From my understanding, I thought the waste generated wasn't from their process, but was from the leather industry itself, the 75%. So I'm not taking their waste, but I'm taking the waste from the leather industry, not theirs. I hope I'm answering this. Pardon? Their waste which is contaminated. I don't think I've got a new question clearly, but then what happens to the current waste? I think Edson answered that. How they made research on it with UCPC and interacting with the leather industries. Then question of this data, where I'm getting the statistics from. Unfortunately, I haven't done personal analysis. I'm an individual, I don't have any laboratory connected to. But this is information from articles, from published articles. I believe they are authentic. Then on the corrosive resistant equipment, I didn't, well, it being just a block flow diagram, I didn't get into the exact equipment we'd need to use, whether it would be a centrifuge tank or what, so I didn't get into the exact material we're going to use. I think that would come into at a later stage after the project being approved, maybe, in my opinion. Then, how to introduce potassium? That's a good question, actually. I hadn't thought about that. But I'll need to make more research on that. Then the cost benefits analysis and sustainability. Well, I also didn't illustrate that because, like I said, I just got theory. This is theory. I haven't done real analysis, so I don't have the exact statistics on that. And then the statistics on the growth rate of the fertilizers, those are from published articles on fertilizers worldwide. Thank you. I hope I've answered all your questions.
Thomas, do you have any question?
My only question was regarding the chromium residue, but was covered, of course, already as well.
The chromium residue?
Yeah, exactly. After, what do you do with the chromium waste afterwards? But I think you covered it during your talk in last answering of the questions.
Okay, that's good. At this time, we are going to call Mugalu Julius. It's your time.
Good morning. Yes, I'd like to thank QCPC for this opportunity and the adjudicators for taking their time to come and watch over these presentations. Yes, my name is Mugalu Julius Ntulume, an industrial chemist, and I believe in green chemistry, and I'm a renewable energy enthusiast. My title is Circular Economy in Action, Turning Lime Leather Pale Trimmings into Renewable Energy. The leather industry, as earlier said, generates over 75% waste, solid waste. Yes, this contains proteins, collagen, keratin, and fats. Because the problem statement was about lime leather pale trimmings. So now the challenges that that the leather industry faces include waste management and disposal. Some some tanneries tend to dispose of in landfills, and that would cost. There's disposal cost, okay, and they tend to recycle. I've made some research, and they tend to reuse. They tend to reuse the solid waste. Yeah. The other challenging is environmental pollution. They're trying to address environmental pollution through when they dispose of the lime leather pale trimmings into landfills, they are going to undergo degradation, and that degradation will result into methane, which is problematic to the atmosphere. Methane is a greenhouse gas. And then, which brings me to the third challenge, which is the greenhouse gas emissions that would be caused by the poor disposal of the lime leather pale trimmings. My solution is anaerobic digestion of the lime leather pale trimmings. The solution aims to create biogas. Yes, it's going to be a biological process, chemicals of life. And then there's a digested, a nutrient-rich byproduct. We'll see all that in detail later. It is a sustainable solution, and then it is cost-effective and environmentally friendly because the methane that is going to be created through the digestion is going to be used to generate energy. And it aligns with circular economy principles. Therefore, all the waste that is created from the tannery industries, the solid waste, will be used as a substrate for the microorganisms to create the methane and then digest it. How it works. Oh, this is not clear. Okay. Made an image, I created an image there. It shows the cycle of the process. But it involves hydrolysis. Excuse me. No. I want to be able to see my... Yeah, I want to be able to see what I am presenting. It's a problem. Okay, it's alright. Okay. The first process. This is what the chart is trying to show is the steps that are going to take place during anaerobic digestion. But first and foremost, we have the solid waste has to undergo pretreatment. Okay, so this pretreatment will make it easy for the microorganisms to break down the waste into the desired product. So the pretreatment will involve shredding into smaller pieces, washing out the lime, and there's a problem of chromium. Then there are three methods that can be done. There's precipitation, and then there's introduction of an adsorbent. But I've not made a lot of research about that, but there's a lot in literature in my abstract in a Word document. And then after the pretreatment is done, then hydrolysis will take place. For this hydrolysis to take place, it's not going to be just hazy. We are going to require a CSTR, a continuous stirred tank.
Yes.
That's where the anaerobic digestion will take place. So yes, indeed, this project requires capital investment, and for it to function properly, because the microorganisms require specific conditions in order to undergo all these different phases and create the desired product. So the first process would be hydrolysis, which breaks down the complex proteins into smaller substrate, and then acidogenesis, and then acetogenesis, and then finally methanogenesis. And in my presentation, as you can see, we are going to have to inoculate, introducing microorganisms to break down the solid waste into the desired product. So we'll need proteolytic bacteria, pseudogenic bacteria, acetogenic and methanogenic bacteria. Sources can be from manure. Tanneries tend to have contracts or with farms, cattle farms, or tend to have their own farms. So manure would be easy for them to acquire. Yes. Let's continue. Why anaerobic digestion for leather waste? Cost savings. Finances can be this specific industry undertakes anaerobic digestion. It will be able to save money that it would have spent on disposal. And then it will be able to generate energy for its use, and it can also sell the energy in form of the biogas. They usually say it in terms of meters cubic meters. So they'll be able to generate income from biogas sales, and then the sale of the nutrient-rich digested. The nutrient-rich digested can be used as a fertilizer. Of course, it needs further pretreatment before it can turn into a fertilizer. And then the industry will be able to undergo regulatory compliance. As Edison said, tannery industries are suffering from a lack of innovation, and the fact that they are wasteful, they create a lot of waste, so they are not compliant to regulations because they are creating waste and they fail to find a solution for the waste. But with anaerobic digestion, the tannery would be able to generate energy and be compliant to the regulations. It is sustainable because an enhancement would make us this specific tannery more popular, and it being popular means that it gets more customers because it complies and it is sustainable. It is following, the solution is following specific SDGs that are widely recognized worldwide, and it would create a brand reputation that is long, that has a long shelf life. So in other words, it would get customers, due to the building of a brand. In this slide, that's the market potential. There's a growing market for renewable energy and waste management. Currently, in 2022 and 2023, the biogas market value was estimated to be worth 47.8 7 billion US dollars, and 62.3 billion US dollars last year. And with some economic evaluation and estimations from the economist's literature, I was able to find out that in about 10 years the market would have grown to about 81.79 billion. So it is a really profitable business to be able to sell biogas. And I created a line graph to interpolate, to try and interpolate and get to know the growth spectrum of the market that I'm trying to deal with. Environmental impact. With anaerobic digestion, emissions to the environment would reduce due to the capture of the methane, and that would create a reduction in the greenhouse gases. Then there will be pollution prevention, would avoid soil and water contamination. And then there's resource recovery, because now they are not throwing away the waste, they are reusing or repurposing to feed. They are reusing the organic material, which is the waste. So in other words, there will be little to no wastage of the hide. There are different case studies, cases where anaerobic digestion has been a success. Of course, these tanneries don't tend to share that information, but they just share snippets that they have done this and that. And these are widely known tanneries. Alpina Tannery, Hella Leather. Alpina is in Italy. Hella Leather is in Germany. Then there is Arihan Tannery in India, and then Tata International Leather Exports. They all adopted anaerobic digestion. There are always risks in business, and the risks we have here include high initial investment, but it can be mitigated by the government subsidies and grants. Since it's tackling sustainable development goals, there's a possibility of government offering subsidies and rich people coming out and offering grants, so that something like this can reach fruition. Then there's a problem of technical expertise that can be solved by sourcing people who have better knowledge of anaerobic digestion. And then feed variability, to ensure a steady waste supply through contracts with tanneries. So since it's going to be taken on by tanneries, these tanneries can also get into contact with other tanneries as well. If they can't choose, since if other tanneries fail to reuse or repurpose their waste, this specific tannery can simply take the waste off their hands and then use it to manufacture the biogas. Yeah. So those are the risks. The other risk would be, I forgot to add it there, would be the low carbon to nitrogen ratio, but it can be solved with using co-digestion, meaning that we don't just digest the solid waste. We can also get feedstock, other sources of feedstock from like sawdust, bagasse, to increase the carbon to nitrogen ratio, since nitrogen production in other words, circular economy, and then climate action, which is goal 13, due to the control of greenhouse gas emissions. That is my presentation. Thank you very much. My name is Mugalu.
So we'll have the jury for comments, inquiries, as we did last round. We have those questions, you write them, you address all those. Thank you.
Things for nothing, Vinji for nothing. That's it.
Thank you, Mugaru, for that nice presentation. When you are closing, you touched my question that was reaching me. How are you going to handle the hydrogen sulfide? How are you going to handle the sulfur dioxide and the ammonia? I can see you bringing in co-digestion. I think that one can address the ammonia, but the hydrogen sulfide, you expect it to be generated. So you should think of considering purification of the biogas. It does not come out clean as it so appears. So there should be provision for capturing the hydrogen sulfide. Why anaerobic? I think this is basic science. Why not aerobic? And then which microorganism? You were not very clear which species of the microorganisms and where are you picking them from? Because you will not just pick any microorganism to be in the digester. Thank you.
Thank you, Julius. First is a clarification. This waste, clarify, you talked over arresting methane gas. Methane. Clarify, do you want to produce methane gas at the end of the process? Because I'm very much interested in methane gas. We are developing a methane gas stove to replace all the gas stoves you see using LPG and others. We're actually already designing and already assembling to develop methane gas stove to take away the challenges of deforestation and the use of charcoal and the effects associated with the same. So just want to have some comfort that you are able to produce some methane, which we can, because our source is cow dung. The partners we're working with who are developing this system. Because, like I said, what we do is support innovation-driven enterprises. And if you'd have a solution, then you'd be joining that class of the innovation-driven enterprises. So give me comfort that you can produce methane gas for us. And in addition to the cow dung that we are using, we can also have more methane gas from this your process. Thank you.
I think he's practically asked the question I was going to ask, because, you know, one of the biggest issues these days is deforestation. A lot of schools, they say we're trying to plant more trees, but at the same time, the rate at which trees are being planted is the rate at which they're being uprooted. So I don't know what is being done right now, you know, say. And then also Kenya has it that they can commercialize their forests, but they can't buy wood, which means they get all our wood from Uganda, which is very bad. So this is actually very good what you're trying to do. Now Uganda's got, I'm not into the energy department, but I know Uganda is producing around roughly 860 or so megawatts of power. And I think that's what they're utilizing. But what is being produced is around 1,400. So we have 600 megawatts wasted. And yet LPG gas is still expensive. So for this actually to work, for you guys to work, I mean, for SMEs to utilize this curve you said the curve is going up. You need to bring out the cost. I mean, I don't know if this will be the best platform for that, because this is how you're going to introduce it into this ambitious tenfold strategy of where Uganda is going to. Because the main concept, I mean, one of the biggest ingredients for SMEs is power. If you give them zero power value, of course the cost of production is going to be very low. I mean, so this is going to be very good. This is actually very good. But how much renewable part you're going to put in the system, what you want, especially government, because you said you want government to be intervened. We are doing a lot of strategies to make sure that we create this enabling environment for SMEs to celebrate their second, third birthday by doing common user facility centers, STI packs. Here's an STI pack that they're producing. All that needs energy. What type of energy is going to produce, how much you can produce, how you can sustain it is really going to be very good. But this is, for the start, it's really very profitable.
Thank you very much, Julius, for that interesting presentation. My concern with the biogas digesters is the management of the digest, the sludge. You talked of, in your stages, that you are going to pre-treat the solid. I don't know by what it means. Now, when you pre-treat and get the sludge and do the gas production, how are you going to manage that sludge? Are you sure that it has been eliminated of the chromium, which you want to reduce in the environment? You could be introducing it from one stage to another. Secondly, how are you going to control the system, as my colleague put it, of selective production of methane, and you reduce the byproducts of hydrogen sulfide, the sulfur dioxide, which could be another problem. Because one of the principles of green chemistry is to reduce the byproducts or the regeneration of other products. How are you going to control that?
I just wanted to re-emphasize the point, because somewhere at the beginning you had a particular waste stream. So I think it goes back to what he's saying. You need to refine that in the choice of raw material, because it will even reduce the sludge volume. Are you going to consider chromium contaminated by the material? I mean, if you don't have that selectivity point of view in terms of what you want to feed into the biodigester, problem.
So last, do you have any question or comment from Thomas before we?
Yes,
before we
nice.
we give him the mic to answer.
Yeah, can you hear me?
Yes, we can.
Okay. So indeed, I have also about 2 or 3 questions. One of them is, what's the price for the microorganisms? Is it feasible? That's the first one. Then the other one is also going towards the chromium waste. Indeed, where does the chromium waste go? Because you, of course, want to digest stuff, but of course, you want to make methane, for example. Chromium needs to go somewhere. Where does it go? What do you do with it? This were also things that the other teams needed to deal with. And then you mentioned, as my third question, that you could make fertilizer from the rest organic matter that's left afterwards, and that would need an additional treatment as well. Would it be like with the other team that you need to add phosphorus to that as well, or what are you planning to do with that? And as I'm comparing all of these three talks and pitches. One is about energy, the other one is about feed production or nutrition, and the other one is for fertilizers. I'm of course not familiar with what is the biggest problems in your country, but what is, I want to maybe also hear me as a naive person here online, what is your opinion on what is the biggest problem? Would you need energy, fertilizer, or nutrition most at the moment? Thank you.
Thank you, Thomas. And we are giving you the mic to answer, to address those issues. Thank you.
All right. In my opinion, let me first answer his question. In my opinion, I believe energy is a very important factor in a country. It runs almost every industry requires energy. So I believe energy is very important in a country. I wouldn't weigh it against fertilizer and feeds, but energy is very important indeed. I mean, we are using energy right now. So another source of energy in a country would be very, very relevant and important. And the price of microbes, the price of the microorganisms, as I said earlier, it wouldn't be as costly since tanneries tend to have farms for cattle. And as I said earlier, in my project, I plan to acquire the microorganisms from the manure. Yes. And about what microorganisms that I intend to use, I intend to use for acidogen. I intend to use during the acidogenesis, the Clostridium species would be most feasible. Then acetogenesis, during the acetogenesis process, then there's that Centrophomonas species of bacteria. Then methanogenic bacteria, a species known as Methanospirillum, which can be got from manure. But I intend to make more research when given the fundings. There's a question that came up whether the process really does produce methane. Yes, indeed, it produces methane. Based on literature, of course, I haven't done it, but based on literature, the highest performance I've seen with co-digestion was about 75% methane. Yes. And minus co-digestion, it would give you, the highest would be 55% methane, the highest, due to that problem of the carbon to nitrogen ratio. And then how to handle chromium. I intend to, in my project, I was proposing to first precipitate, as I said, first precipitate the chromium ions out using sodium hydroxide probably. Yeah, and then chromium can be used for other purposes, like in metallurgy. Yeah, and then yes, hydrogen sulfide is generated, and other things, even carbon dioxide, they're generated, but I hadn't gone that deep into detail to solve that problem. But in my abstract, I got a few solutions, but the ones I got for ammonia stripping. But then I didn't go as far into the purification. My intention was to voice out the fact that the solid waste can really generate what? Methane. Yes, those are the questions. I hope I've answered them all.
Hand of applause to Mungalu. And at this
Thank
moment,
you very much.
You're welcome. And at this moment, we are going to have Nachimba Anita.
Good afternoon, everyone. My name is Anita Nachimba, and I'm an energy enthusiast. I work with Hima Cement. Nice to meet you all. So today we want us to first imagine turning one of those most polluting wastes from an industrial waste that we have into not just a solution, but rather an opportunity. And however, even you can imagine that there is cash in your trash. So today, I'm here to present to you how we can turn lime leather pelt trimmings at 60 or more % of the tannery industry into ingenious solutions I have. So the tannery industry is an environmental hotspot that generates over 60% or 75%, like my colleagues have mentioned before, of its waste, which contributes significantly to the environmental pollution, and rather they don't have even like solutions to that waste. That's one of the first problem. Then also, with our country running towards renewable energy, another problem we have is we are relying mostly on fossil fuels. So my solutions today is going to focus on solving these two problems, the tannery waste and also the energy demand that is rising over and over. My first solution is fat extraction. If we have this tannery waste and we extract fat from it and we make soap from the fat that is being extracted from the lime leather peltings, we can make soap. Then my second solution is pyrolysis conversion. Pyrolysis conversion involves turning this waste into energy products. And these energy products, actually we have energy products and also some products, the byproducts that we can use for agricultural use. And as well the bio-oil. So with pyrolysis, we have three products. We have the biochar, the bio-oil, the syngas that we can reproduce and solve the problem of and create products for renewable energy that also bring sustainability. I'll first go through the technical overview. Now, fat extraction is the process, or call it saponification, where lime, and this can be done by using hydrochloric acid to remove the lime, which also helps us adjust the pH. Then the fat, this is based on a pilot study used on a lab scale. We use an apparatus, or on an industrial scale, that's when you use a reactor. And using diether as your solvent to extract this fat out of the trimmings. Then this fat undergoes saponification, where you react with sodium hydroxide to create the soap, and then glycerin. In addition, you're also creating now glycerin as your other byproduct, which can also now be used in cosmetics. So you don't have any product that's going to a waste. You're producing soap at the same time, you're also producing glycerin, which can be used in pharmaceuticals or in cosmetics. With the pyrolysis process, here I plan to use aspen. with everyone getting to process simulations or developing using process or any dynamic model, I intend to use Aspen simulation, where here you conduct a feasibility study of the peel trimmings. You're having the peel trimmings that contain collagen, they contain the other element, the fat, they contain the other gases, and you're going to burn them. And when you're burning them, you're producing the bio oil, the syngas, and the biochar as your products. So this Aspen is helping me come up with a thermodynamic study of my process, as this is my feedstock, and I'm having 3 products coming out. You're going to pre-treat, you're going to wash your peels and remove all the moisture. You're using basically water. After washing, you're going to burn them into a pyrolysis reactor. And in the pyrolysis reactor, first of all, it's under controlled conditions. And under controlled conditions, you're burning between temperatures of 300 to 700, and it's an absence of oxygen. So with your pyrolysis, you're creating 3 products. That's about the technical overview. So the go-to-go market strategy of this project is, first, you test your fat extraction in the lab scale to see how much of those products you're going to produce. Second, also developing the simulation for the pyrolysis conversion you're having. Phase 2 involves scaling up your process. You're moving from the lab scale now to an industrial scale to see the feasibility of the soap you're making, how the consumers, how are they using it, is it effective, and also the energy now you're producing, because you're selling the syngas, which contains methane only, because in your process you'll have to purify. Syngas is a mixture of methane, carbon dioxide, hydrogen. These gases, after purification, you can as well sell them, and then maintain the methane, which gives you the energy. For the biochar, which would have been the ash, this is an agricultural use that also helps farmers in fertility. You can use it in the gardens for fertility, and also some people use it for water purification as an adsorbent as well. The bio oil now. The bio oil is also a fuel. This fuel, with also where I work, say Himasemen, or this is a fuel that can be used in boilers or kilns. So with also that part of the industry, we are all running towards green chemistry. And everyone knows that cement industry is one of the industry that produces a lot of carbon dioxide emissions. And nowadays, we are transforming from using coal, which is a fossil fuel, to using biomass. Because now you see we go to farmers and give them produces, and they give us the biomass, which contains the husks, the coffee husks, the palm kernel. We all use all that biomass to burn in the kiln. And we're substituting that biomass, all the bio oil, 60%, and we're using 30% coal. But imagine, and this thermal rate substitution is able to reduce carbon dioxide emission by 49%. So if we also have this bio oil coming from the pyrolysis, we are further reducing, instead of even using coal, the 30%, we could use the bio oil, which helps us to burn. So on that all involved in my phase 2 of scaling up your processes and making sure that with circular economy, you don't generate more waste in the environment. Or you even actually helping other industries reduce the carbon dioxide emissions they are producing. You're also helping farmers with the fertility of their soil and so forth. Then phase 2 involves market expansion, whereby now you're having to diversify your byproducts. Say the byproducts from soap, which is glycerin, you're having it to sell it to the pharmaceuticals or the cosmetics for their use. Every day we have to smear Vaseline before you come to work. So you all need all pharmaceuticals. If you're making medicines, you have to make medicines for that. For the pyrolysis process in phase 3, we aim at scaling up globally with partnerships, because it's an investment. A continuous feed pyrolysis reactor is quite expensive. It's an investment you're having. So partnerships can help you invest in the project. So the market opportunity about these two solutions is, first of all, you're creating renewable energy and bio-oil from the tannery waste, which can meet the growing demand of the sustainable energy source. Then also, you're helping agriculturalists. The biochar you're producing from the pyrolysis offers profitable solution for soil improvement and carbon capture. Thirdly, you're having the growing soap demand. Most of our soaps we use, people are using Dove, you're using any of all the soaps you know, they are coming from outside. How about actually even instead of maybe cutting down trees for palm oil, for palm trees, we use this waste that we have to generate soap, other than even importing. So this, and with the population also growing, we can use the fat, we can extract the fat from the waste to make soap. Then it's a waste management need that it's creating circular economy and we're preventing the tannery waste from having this waste. Then lastly, the bioproduct diversification of the glycerin, which is also like it's a market opportunity that you'll be selling the glycerin. Now with the market projections, according to the Global Market Statistics Report and data, the global bioenergy oil market is projected to reach 320 billion by 2030, and with a compound annual growth rate of 6.5%. This shows that with your products, you're producing the bio-oil in the different countries, as we are going to see in the economic overview, they have a 6.5% of growing. And also the investors, by 2030, people who want to invest in this bioenergy business, the rate is growing by 6.5%, which is about 20 million if you own your investment, as I'll explain. So then thirdly, the global waste to value market is also growing. Waste, like I mentioned earlier, like nowadays we are using husks, the coffee husks. We're no longer leaving them in the community. We use the coffee husks, we use the rice husks, we use the pumpkin husks. Any husk you know of a biomass, we use it now for burning. So if that waste of market value is also growing through circular economy by 55 billion in 2024 currently, and it's projected to grow by 8%. Now, if we also get the tannery waste and we're also converting it into energy, all other products, we're also contributing to the 8% or even more. Then also, according to the Congregative Market Research, the East African soap is estimated at 2 billion, increasing the demand of the cost, with also the population we are having growing each and every day, and also the soap demand coming high. You don't want maybe to buy a soap actually of 50,000. How about to get the waste we have and you also make soap out of this? And remember, like I said, instead of actually cutting down this palm, the time I was in the ginger company that makes soap, you would find that they would go a month without the palm oil, and maybe they're telling you farmers are not bringing palm oil, which they're even actually exporting from far different countries. How about we use this waste, the tannery waste that has even collagen and the fats we can extract from to make the soap. Now the competitive advantage of these two solutions is, one, it addresses sustainability. It's transforming the waste into valuable products. Then number two, it aligns with the market. It meets the growing demand and the increasing of the consumer demand for affordable and locally made produced soap, plus the renewable energy solutions. Secondly, it's cost effective. Being cost effective is that it can actually generate, if the tannery industry doesn't have, okay, not like doesn't have, but their waste is accumulating, they actually now have. So we can buy it at a lower cost, or it can be a memorandum of understanding between the person who wants to invest and them. And then they are generating income as well, but also this person who is making their business is also going to make money out of it. And you're using the waste at a cheaper price than you using raw materials that would have been at a higher price. Then also the proven technologies, pyrolysis and soap extraction, these have all proven technologies and technologies that are well on market that can incur just experts to come up with a feasible project on ground. Now, my business model involves revenue. First, the sales from soap. Someone would ask how. Now the sales from soap, imagine we get 1 ton of this tannery waste. From 1 ton, according to our region in East Africa, our fat, the pelled leather trimmings contain about 6 to 15% of the fat. And with your process that has 80 to 90% efficiency, you're going to have the fat. You have a process that is 80 to 90% efficient, and you have 6 to 15% of your fat in the waste you have. Then we know that 1 kilogram of fat actually gives you 1.2 grams of soap. If it gives you 1.2 grams of soap, and it's going to give you 0.1 to 0.15 kilograms of glycerin. So we want to convert our soap, the 1 ton, I'm giving an estimate of the 1 ton of the waste I have into soap. So if I have 15, say I'm taking now an instance of 15%. From 15% fat from my waste, that means I have 150 kilograms of fat. That's on weight. So if I have 15% of fat, and that's say 100 kilograms of fat generally now from my 1 ton, and with my 90% efficiency of my equipment, at 15% that will reduce to 135 kilograms. 135 kilograms now I have, and we say that 1 kilogram of fat contains 1.2 kilograms of soap. So with the 135 kilograms of soap, I'm having 162 grams of soap now. From the 135 kilograms of fat, I've made 162 kilograms of soap. And then since we say that 1 kilogram of fat gives you 0.1 to 1.0 kilograms of glycerin, that means I have about 25 kilograms of glycerin. So on your cost input, you're having, I made an estimation on a lab scale or on a parallel study using my Zolix apparatus. And my input of the chemical you're going to use, you're using diether and hydrochloric acid to delime or adjust the pH. Plus any additives, say, for making your soap have a nice scent. When you add all the costs involved, it's about 600 per the ton you're having. It's something you move from 1 kilogram to a ton. So when I did that cost analysis, if I invest 600,000, that my profits if I have made 162 kilograms of soap, and we know that right now a bar of soap costs say 8,000. So 8,000 multiplied by the 162 kilograms, I have 1.2. Meaning from my 600,000, I'm able to get twice from the investment I've made, from 600 to 1.2 million. And then also I have my glycerin. Glycerin right now on the market is 25 per kilogram. So if I've made 25 kilograms and I also sell them, I'm having around 1.6, and in addition to the soap I've also made. So there is a very big profit from the fats or from the waste that you're making from soap. Those are the sales I'm talking about, that you're going to be able to make the soaps from what you actually invested in. So if you scale this also on an industrial scale, I'm sure you'll get more and more profit. So for the pyrolysis, you're here selling. You have sales from the biochar, the bio-oil, and the syngas. Now, on 1 ton of your feedstock now in your continuous pyrolysis reactor, the bio-oil comes out as 25% of 1 ton. Then the biochar comes out as 45%, while the syngas comes out as 15%. With that in mind, so if you have 35% of the bio-oil, this can be sold to the company, like to the people who use the bio-oil. I give an example of my workplace. We use this in big amounts, and we're actually reducing carbon dioxide emissions. Then for the biochar as well, you're giving it to the agriculturalists to improve their soil from the farms. Likewise, to the syngas after purification, the methane gas is also going to provide the energy. Then another cells, the cells from Greenchem, which I also talked about. From there, another point in the business model involves partnerships. You can't do this without partnerships. So that's why you need partnerships from investors, energy companies, and also local distributors. Every year, we always have the Renewable Energy Expo. And this is where all these, you find people making up all these. That's where you could actually go and have investors. You talk to investors, investors always come, and you also see what other people in the renewable energy sector are also coming up with, which makes this project a very good one, because you're also going to get another exposure for people to invest in your business. With a color, first and foremost, you're minimizing costs because you're using a waste that is being generated by another industry. Secondly, it requires investment, coming up with the extraction and also the processing equipment. With the impact matrix, first of all, it addresses the environmental aspects, that you're reducing the 60 or 75% pollution, because remember this, the waste that you have once in the air or water, it pollutes the environment. Then economically, you have an additional income. It also creates jobs and affordable byproducts that you can easily sell. Otherwise, thank you for listening. Yeah.
We are going to, for our routine, the jury will have the comments and the questions and the inquiries after that. And I've received notification from the lunch team. They are telling me at 1:30. So we are going to be swifter. 10 minutes will be now more tight to 10. Let us make the presentation really 10 minutes. Thank you.
Thank you. Thank you, Madam Anita. It's quite a mouthful, and thank you for the presentation. But I wanted to look at the critical analysis of availability. You told me, okay, you told the audience that the technologies are available. Can I ask one? In your analysis, are there already available technologies readily using leather waste? And we just simply leapfrog. Because I'm looking at the cost of the reactor, which could not be there using leather waste, and you have other forms of producing soap, for example. If you look at the cost of production of the current cost, the current production costs and the current methods, if you compare it with what you want to introduce or you are trying to put on the market, what is cost effective? Okay, there are advantages, like you have pulled them out, but is it worth? I mean, what is the volume of waste you expect from the tanneries? From what Edson was presenting, there are only 2 active tanneries in the country. Do you foresee yourself, after investing in a reactor, which is very expensive, and you reach at this point and there's no feedstock? Okay? So I'm looking at sustainability over time. If we get a very expensive reactor, and these guys are producing soap, and you don't have the feedstock, what happens? It all goes about market analysis and the technology. Thank you.
Thank you, Anita, for a very elaborative presentation. But the challenge we are having with the waste from the tannery industry is chromium. In all the processes you've given us, I've not picked out clearly how you are going to deal with the elimination or removal of this challenge, because the reason why we are not utilizing that waste currently, because of its contamination. So in your processes, I've not been convinced on how you are going to eliminate chromium with all the processes you are proposing. And lastly, I thought pyrolysis is an energy involving process. Of course, it doesn't use oxygen. You heat in absence of oxygen, but it is an energy involving. Don't you think you are, as you want to solve the energy crisis problem, then you are introducing a process which is energy consuming? Thank you.
Thank you, Anita. The question is to do with the chemicals, the diethyl ether. How environmentally friendly is it? Couldn't you think of another alternative to diethyl ether? Thank you.
Thank you, Anita. You talked of providing, I just want you to clarify if you're going to produce green boiler fuel as an alternative to what we have, the biomass, heavy fuel oils, LPG and others. Clarify if your innovation is going to lead into production of some green boiler fuel. Secondly, you want to use fats from the tannery to produce soap. I want you also to clarify or to highlight the advantages of using your fats compared to using plant oils, palm kernel, sunflower, and other plant oils. On your last slide, you did talk about the impact in terms of job creation. So I want you to, if for example you're supported and this your idea is taken up, how many jobs are you looking at creating? Secondly, quantitatively, how would your idea contribute to economic development of this country if it is supported? So I want you to just throw more. By the way, this question, the last two, goes to all other people who have presented. Go back and look at how your ideas, if supported, how many jobs are you going to create? Because in Uganda, as government, we want to see that ideas create jobs because we want to alleviate poverty. We want to improve economic support to all Ugandans. Every Ugandan should be employed. So how many jobs is your idea going to create? Then what is your economic impact? Even those who presented, please think about it, because a very good fund or investor should hear those. Oh, you're going to create jobs. You're going to improve the economic development of this country. Please, even those who presented, think about it, answer it. But for you, answer it here. Thank you very much.
Yes, thank you, Anita, for that presentation. I think after this, what I call pitches, I'll become a chemist. I think UCPC should give me a certificate of chemicals. I've had terminology which is totally different from high frequency. Anyway, you see in government, there are problems also in government. You know, they keep on making policies and failing to implement them. Okay, so NPA came up with the suggestion of going from sector-based to program-based. So when you look at all these pictures, they are actually heading to mainly 3 programs. 1, reducing waste. 2, increasing what they call renewable energy. And there's the 3rd one, of course, feeds. So I think not to scramble, because you know right now all the ministries come up with programs and they start scrambling for funds to show that they have the mandate to propel them, to activate them. But I see all of you with the pictures with very good innovative ideas, okay? To not lose concept, to make sure the work makes the work. I think some of you need to start networking with each other, you know, come up with a one, because now you have come up with a totally different concept of fats, of byproducts, and another one is coming up with a different product. So you may both lose in the, but if you network together and come up with that and come up and approach the ministry and say, this is what we've come up with. Because I assure you we are in NDP4, and this is the direction the government is going to. But once again, thank you very much for that presentation.
Thank you, Anita, for the nice presentation and so detailed. My concern is similar to the first question. Yes, John it was about chromes. And I was wondering, also I didn't hear anything. And then I was wondering how safe is this soap and glycerin to human? Yes, thank you.
All right, I think I'll start with the lady. About chromium, the pearl trimmings come into various versions. There are those before they actually turn. Then there are those before and then after. For the purposes of the project, we are considering those before, the trimmings, according to the way the abstract was actually explained to us, those before the trimming. However, also with the chromium, in case the chromium is involving substance of purification in your process, you purify after turning. You could purify in the process that you have. You could actually use activated carbon or inside the reactor, because actually if you have chromium in your reactor, could actually cause the process to cause deviations from your process, or coatings, or in the reactor you have. So basically with the pyrolysis part, you're actually aiming at mainly the trimmings before, those that are before the turning. Then the technology is available, yes. With the soap extraction, this has actually been proven in Nigeria. I have a colleague who actually does this with the soap extraction, who gets the tannins from their industry and makes the soap out of it. How safe the soap is, during the process, you actually have to, because you have acids coming in. That's what I said in the beginning, you have to actually check your pH. You add a little acid of hydrochloric acid to check your pH. You don't want a soap that is going to burn people's skins. You do various optimization of your process. You check the temperature. How much of the fat can you yield from using the dial ether? Or how much of the acidity do you have in your soap before you actually put it on the market? That's why it's very important to do the lab scale of that soap using the Zolix apparatus. So when you use it, actually you confirm the product you have. You have to check the acidity and other parameters. The iodine inside all the parameters of soap, you have to first check them. Then about using another alternative aside diether, I'll probably have to, because it's the extracting solvent you're using. So I'll actually do myself a very good research to think about an alternative one. Yeah, thank you.
So,
I think the gentleman talked about the economic value of the project, how many jobs you're creating. With the current, first of all, if we have various tannery industries, you have people, the jobs, say, collecting the waste. That's one of it. From collecting the waste, you have people maybe operating or making soap. Those are also other job opportunities you're also creating. People making maybe the energy, that's another sector you're also creating. So I feel there are various jobs that people are coming up, like maybe those making soap, packing soap, or those that are running the equipment. I feel there are very various jobs that you're creating. I don't know if I've really answered the question, but yeah.
Thank you very much for that presentation. Some of the questions came in, and I feel I should talk about the green chemistry for sustainability. It's a platform. So maybe what you can do, we shall share a link. There is a community of chemical engineers, people with background in chemistry, experts, who are willing to collaborate with researchers globally. So if you want to network, if you want to build your network, you could log in. Then they also talked about safe alternatives. If you are doing research and you want to know which other safe alternatives are there, log in, you can register, be a member, and then there are tools that can guide you find alternative safe chemicals. And I will also encourage you to visit and be members. There's a lot of opportunities. If you want to find funding, there's also a window for that. You can go in and look for funders who are willing to invest in similar solutions you are trying to develop. But tomorrow we shall give details about this. And engineer, you are worried about cisternaries are closed and they cannot get raw materials. So it will be an advantage to her. Because for you, keep eating meat. And the hides will keep coming. Exactly. So she will have more raw materials. Don't worry about the sustainability of that. Thank you.
Lastly, if there is a question from Thomas.
Yes, sorry, I don't have any questions. Other jury members were asking the questions already, so thank you.
Okay. Thank you, Anita, for that presentation.
Thank you.
And we have about 30 minutes, and we want to squeeze in 2 people before the 1:30 I talked about the lunch. And we are going to be swift. The 10 will be 10. At this time, let's have Joy Asimwe for your presentation.
Thank you so much. I think it's good afternoon. Good afternoon, everyone. My name is Asimwe Joy Maska, and right now I work with Coca-Cola Beverages Uganda under the logistics department. So as all the other people have been presenting, the problem presented to us is the leather pale trimmings that come from the leather industries. And this innovative idea is to transform these lime leather pale trimmings into a high-value biogas, of which it will lead to a sustainable economic growth. So, for our problem statement, we see that Uganda, of course, it has identified a leather industry as one of the value addition chains, and it's growing rapidly. So, through this, a lot of waste is being generated, and of which particularly lime leather pale trimmings is one of them, which is a solid waste. This waste has posed great, significant environmental problems because if at all other tanneries have been closed out, that means they're not complying to the standards that have been set by NEMA. So that's why they've been closed out. And as well as a waste management problem, because if at all we are not managing these wastes, that means they're going into the environment, first of all leading to pollution because they are organic, they are going to decompose, they will lead to air pollution because the smell coming from it, I believe if you are nearby and maybe you pass, you wouldn't want to stay there maybe for like even 1 second. Then also we see that if these go into the water fields, they are going to contaminate the water as well. For example, because they contain lime, so it wouldn't be good into the water. So, but despite all that, the current disposal practices which the lime leather industries are carrying out are not that sustainable. For example, landfilling, incineration, all these, yes, you can do them, but they cannot sustain us in the long run, and we see that they have led to contribution to pollution and resource inefficiency. Resource inefficiency in a way of these trimmings that are discarded can be turned into a great product for us. So the idea is to turn these trimmings into high-value biogas through proven biorefinery technologies, one of which I'm going to capitalize on is anaerobic digestion for this process. And this anaerobic digestion is going to help us to mitigate environmental impact, of which the environmental impact we saw that we are facing pollution from these wastes that are being discarded. And at the end of it also there will be resource efficiency because we saw that these wastes are not being utilized. So if at all we can utilize them, that means another source for us. Then as well as provide economic benefit to the country and everyone else, because if at all we turn it into biogas, that means we are providing another economic way, because we shall sell this biogas to different people, and as well as we shall utilize it we ourselves. So that means it's making the country develop greatly. Then as well as support sustainable economic growth in Uganda by optimizing processes for local conditions, because at the end of it all, this technology that I'm going to use, it has to be optimized for us to get the optimal biogas from the process, and also we shall engage the community. Then our target market, first of all, is the leather tanning industry. Why the need is because we need sustainable waste management solutions which are cost effective, and biogas production will be one of them. Then also the energy sector will be our target market, because they require reliable and sustainable raw materials for biogas production. So if at all we can give them an alternative of these resources, that means there's going to be increased biogas production. And if at all there's increased biogas production, that means we are increasing onto, we're having an alternative energy source. And just like we said, we can't be there without energy. Energy is used for so many things. Just like right now, we are using energy. And also we see that energy is used in cooking. I believe most of you have gas at home, or you have electric cookers. So all this is needed. Then we see also local communities, like everyone else here. If at all we cannot involve the community, and these are the people that need the solutions, despite the fact that the industry is facing this problem, but if at all we don't engage the community that needs this biogas, that means we cannot sell it off. So we need to involve the community, and also the need is because there's high demand for clean energy solutions, because we see that the existing methods for energy that we use, for example, firewood, charcoal, all those produce a lot of carbon dioxide, and they contribute to the carbon footprint, of which the action is for us to reduce on that carbon footprint. So if at all we can provide the communities with a clean energy solution, then it would be best for each one of us, because also it will lead to good health, which is one of the sustainable SDGs, the goals that we are chasing. Then the agricultural sector will also be a target market. In here, we are providing them as well with affordable and sustainable energy, because most of them carry out irrigation. And irrigation sometimes is aided by, we have to maybe use energy to drive these motors and all that. So if at all we can provide them with a cheaper way through the biogas that will be produced, then it will facilitate the operations in the farming, then as well as the organic waste that will come out after the digestion process, as we shall see. Then the market opportunity that is identified, we see that there's sustainability and environmental benefits. In here, we are addressing the environmental impact of the lime leather pale trimmings through biogas production. In a way of, we saw that these are the wastes that are causing significant environmental issues. So if at all we can turn them into a valuable product, that means we are improving sustainability and also improving on our environment, because that means then the leather industries will comply with the standards set by the NEMA and be able to operate without being closed out. Then we also see economic growth and job creation. In a way of, we are going to create new opportunities for people, because if at all this is supported and funded through people coming to invest into this idea, and we set up each and everything, that means we are going to create opportunities for people right away from sourcing these raw materials, which will be the lime leather pale trimmings, to the end point whereby we shall be selling, as well as also to the agricultural lists. Then economic growth, of course, like if everyone is getting something, that means we are doing well, and the country will really, we are able to contribute towards the taxpayer and all that. So then also we have energy security and independence. So of course, we do not want to rely on one energy source. We want to have so many alternatives, just like, for example, some of them, yeah, we have hydroelectric power. The existing ones are, we have the coal, like the non-renewable energy sources. But all these ones can be depleted. So if at all we provide a renewable energy source that cannot be depleted in the long run because it will sustain us, then that means there's going to be energy security. We shall not be running on a low, or shall not be scared because we know that energy is there. We have so many alternatives. We have so many things that we can look out to, and as well as independence. We don't have to rely on other countries maybe to provide to us all this. Then policy, support and incentives. If at all we can work with people who make the frameworks and all that to promote this renewable and waste management, then it would be a great opportunity for us. Then the value proposition for this project, we see still sustainable waste management for the leather tanning industry. In a way of, we are managing the waste management challenge that they are facing right now. So that means it's a solution that we are providing towards them. Then also we have production of renewable biogas energy. Just like I've mentioned before, that this biogas energy is going to be used for so many things, because also the leather tanning industry itself, if at all it can employ it, it can act as an energy recovery towards them. That means it's a win-win for both of us. They are turning the waste into energy and they are reusing this energy into the system. That means they are cutting on their costs of energy as well. Then there's reduction in environmental pollution and health hazards. Just like we saw that if at all we continue to just dump these wastes into the landfills and incinerate, we have seen that they are not sustainable enough. Like, we can't keep on discarding them. We also see like the scenario that just happened recently in Chitezi, where waste just collapsed and people died. That means it's not a reliable way of discarding waste. But then if at all we can turn these wastes into biogas, that means we are going to reduce on environmental pollution, and we are creating a safe environment for each and every one. Then as we are going to create economic opportunities as well as create jobs for the local communities. Just like we know, like, employment in Uganda lately is a bit hard. And if at all maybe we can provide someone with an opportunity, or we have so many job creators, then it would be something of a good thing to this economy. Then also we are contributing to the sustainable economic growth, especially the SDGs, affordable energy, health, and well-being of people. So all that is what this idea will bring to us. Then for the technology that we are going to use, just like I mentioned, we are going to use anaerobic digestion. Anaerobic digestion is carried out in absence of oxygen. And the main product that will come out from that will be biogas. And the composition for biogas is basically methane, which is like 60%, and carbon dioxide. And this methane is the one that we capitalize on to make the biogas that supports all these things. So the biogas that is produced is always a renewable energy source. So the process will involve pre-treatment of the feedstock that we shall have picked up, because the lime leather trimmings, we have to first delime them so that we make the process, the digestion process easy for us by removing the lime. So after cleaning the feedstock, then we shall put it into the biodigesters that we shall be using. Then they undergo digestion stages. Under digestion stages, we have hydrolysis, in whereby the organic molecules, the big ones, are converted into the smaller molecules, the small molecules, and this is enabled by the bacteria that is inside. And it's the one which will hydrolyze those. For example, if at all we have protein in it, it will be turned into amylase. Then if at all we have maybe fats, into lipase. So these will further go into another stage called acidogenesis, which is aided by the acidogen bacteria to convert these monomers that have been converted. They'll further be broken down into, it shall further break down into carbonic acid, then also as well as into fatty volatile acids, alcohols, and some of hydrogen will be produced during that acidogenic process. Then from that process, we shall go to acetogenesis, whereby we shall use the aid of an acetogens to break down the fatty volatile acids that have been produced into acetic acid. So this acetic acid at the end of it also one which will go to the final stage, which is methogenesis, whereby it's converted into the methane, the carbon dioxide that will be produced as well. And methane is what we are interested in. But through the entire process, we see that there's going to be digest that will be produced from it. And this digest, we can give it to the farmers, and they use it as fertilizer. Then for process optimization, we can use the existing data that successful case studies have carried out, so as we can improve on our process as we go on in the long run. Then for the competitive objective, we see that this biogas is being produced through anaerobic digestion, and this process is very eco-friendly. So it's going to reduce on the greenhouse gas emissions, the pollutants, hence it's promoting a cleaner environment. So we also see that we are creating a new revenue stream and promoting economic growth and job creations. Then we also see that we are actively engaging local communities. How? We shall train the people and through training and participation, and advocate for supportive policies from government. Hence there we are fostering a sense of ownership, encouraging sustainable practices. Then also we are it will be generating a renewable energy source. This can be used for heating, electricity, fuel reduction or reliance on fossil fuels. Hence we are enhancing on energy security. Then the business model. We have our revenue streams. So our revenue streams shall obtain sales from the biogas that we shall have generated. Here we can sell to the companies, the communities. So through that, we are able to obtain some good amount of money for us. Then also fees for waste management services from the leather tanning industries. Because we are handling their waste, we can come to a memorandum of understanding and be like, yeah, so you're giving us your waste, but maybe you can pay you can give us an incentive, so that maybe in the process of us collecting the waste, then we can also be generating that fee from the waste that we get. Then also shall sell the byproduct to the farmers. Then the cost structure, of course, this project, before maybe, if at all it's put to life and everything, it needs initial starting capital. It will be way too high, but in the long run, because we have to set up the digesters. Yeah, there are some existing digesters in Uganda. We see that the company SNV NGO came up to set up some biodigesters, of which we see that 2 have been closed because they burst out, or some are no longer active because maybe people are no longer using them and all that to me, but I believe maybe because they did not engage the community so much, because most times when we do not engage the community, we see things crumble, because it's the community people that at the end of it all are going to enable us to sustain all these things in the long run when we have all the fundings that we require. Also, we see that operational costs will be high, then research and development expenses, then training community engagement program. That's also a cost that we shall need, because if at all we are to reach out to the communities, how shall we be traveling to reach out to those communities, to engage them and to tell them more about this biogas production process and all that, to engage them. Then also marketing and advocacy expenses. So all those are costs that need money for funding from you guys. But then we see the impact metrics, at the end of it all, what impact is it going to bring? We see there's generation of additional revenue streams from the leather tanneries, because through that we are creating jobs in biogas production and distribution and simulation of local economies. Then we also see that we are going to reduce on pollution of the waste. Like, there's a lot of pollution that is taking place. So if at all we reduce on these waste, that means we are promoting cleaner production. At the end of it all, we have been saying we are focusing on green chemistry, circular economy. So that means we are trying to reduce as well on pollution. Then we also have enhanced energy security, which is going to reduce on dependency on fossil fuels and also contribute to the national energy independency goals, whereby we are all going to have access to affordable and clean energy. Then access to grants, subsidies and tax incentives. This will help to reduce on initial investment costs, just like I had elaborated from the previous slide. Thank you so much.
With my clock here, she will be the last one. However much we have more other presenters around 3 for the afternoon, because we cannot avoid lunch. But I would like to get some inquiries this time, first round from Thomas, in that your inquiries, comments, it's your high time.
Yes, thank you. I have just a short question about, maybe I missed it. How are you dealing exactly with the chromium waste? I feel like it's coming up all the time, but could you give us more details on that?
Okay, thank you. Any other except that?
This peg is also down.
Okay, let's have these the questions from the jury here.
Oh, get this seat.
I think he's satisfied.
No.
He has mentioned it.
I'll sit there during presenting. Yeah.
Thank you very much, Asimwe. Now, you get to understand there are many methods we can use to produce biogas, okay? And specifically methane. I want you, and actually this also goes to all of you who have presented and those who are going to present going forward. The aspect of value proposition from including you and the previous presenters, you are giving value proposition, you're looking at the outcomes or the impact of your project and your endeavor. That's not specifically the value that we want to hear or anyone wants to hear. We want to hear the value of the offering that comes from your process, which you want to be funded, for example. You want to be funded to reuse waste from tannery to produce biogas. Now, when you talk of value proposition, you're talking about the value of the biogas you're producing. Now, you're answering the question, if I drove to Shell or to anywhere and I found 2 12 kg gas cylinders, one is Shell gas, another one is Asime and Daughters Company Limited gas. You're answering the question why I should choose Asime and Company and Daughters gas, and then I leave Shell gas. The value proposition. All of you, those of you who have presented, go and look at that, because the process is a process. You are recycling, you are making use of the waste from tanneries to produce a product or service. What is the value of the service or product to the customer? Me who's coming to buy gas. That's the value proposition, not the outcomes of job. No, those are different. It's a different section. It's very good, it's cute. The jobs, the economic impact, it's cute, it's beautiful. We want to hear it as government. But the customer, the buyer of your offering wants to hear certain things. Is it cheap? Is it, am I going to, if I buy I give an example. Some of the things we need to use real examples. I used to use shale gas, and I would determine how much, if I buy 12 kg, it would last. Then I bought Oryx Energies. And over a period of time, I realized that Oryx Energies takes longer for whatever reason. Maybe the chemistry that you go through to produce it, you're a chemist, you know better. And right now, the shale gas is just there standby in case this one is used up. Yes, the Oryx is the main lady in the house. So, value proposition. Let's look at the value of the offering, not the value of the process. The value of the process is very good for us to know we are going to create jobs, we're going to do this, it is easier to do, it has these risks eliminated. How about the customer who's going to take the offering? Thank you very much.
Let me throw one, huh? Because she has made me joyful. Thank you, Joy, for the presentation. My concern is similar to that of our colleague online. The management of the digest, the sludge, and its quality. Like a colleague who your colleague who submitted for the aerobic digestion, it is still a concern. Huh? I really don't know how you are going to solve that, to be able to convince this panel that you are not transferring another problem. Secondly, on one of your slides, I don't remember which one, you told us that it reduces production of greenhouse gases, yet on the technological, I think there was a slide on technological process, one of the products you gave us was carbon dioxide, and I thought that was a little bit contradictory. Which is which? Thank you.
Okay. Thank you for the questions. I'll start with Thomas. What you asked about how to deal with the chromium waste. Initially, when they proposed that we should come up with the innovative solutions, the most identified waste was the lime leather pale trimmings, and that's what I focused on before tanning maybe the hides and skins before them undergoing the tanning process. But in case we are to consider that waste, that means we shall use the precipitation method probably, or I'll go and do more research about how best we can go about the chromium waste. Then for what Mr. Waswa has asked about the greenhouse gas contribution, the carbon dioxide that will be produced, during our, just like I've said, like this, maybe for the start, we can carry out that, but alongside, I've said we shall do process optimization. We shall see how best we can minimize the carbon dioxide that is coming out. For example, we can use scrubbers. We can include maybe scrubbers into our process so that we can eliminate this carbon dioxide that is being produced in the process. I hope I've answered all the questions. Thank you.
So the presenters who will come, and this is to inform Thomas that we are going to go for a break because he may be off, he may not make it after lunch because we may be with Hano. He will be with Hano. So yeah, indeed, Hano with that, there. Before we'll go for the paint industry, we'll have these last three presentations because the side of leather had a lot of solutions coming up. So the good thing, we have tackled most of the proposed solutions, and the last three, maybe when Thomas will be away, they will be addressed with the jury here, and then also Hano being gone. We don't know whether it's okay with you.
That's okay. I will just do the until now. Yeah, totally fine. Enjoy your lunch, guys.
Okay. Thank you, Thomas, for being around.
Yes.
So for us here, don't leave your ticket. Yeah? This is the ticket. Eh? When the train is moving, you reach there, they will ask you for your ticket. Did you pay the tax fare? So make sure you have this one. And we are going to have a group photo with our jury because some of them may go. So we want to capture them before they go, that they were here. Yeah, so in the evening, we'll have presentations from these last 3 presentations, then after the paint after. So let us make haste to be here by latest 2:15. So we are going to have a very moving, dynamic lunch. So we'll follow the train, but let's have a brief session of photos here, then we go. Thank you. So we'll have our jury. With that, they will be coming first. Thank you. And then your property will be safe here. Eh? Hey, your property will be safe. They will lock. And we'll ensure we go with the key. So we are the gatekeepers. Thank you. Don't forget your fair script.
Your go-to place for all of your print-on-demand needs. Not sure where to begin? Creative Fabrica boasts an upload your own assets, convert image.
like trusts, which again, this cannot be a discussion about how to create a trust. But it's another avenue through which you can seek legal advice. If you have to maintain your
Hano has joined. Hello, hello. Hano, how are you? Sorry for the delay.
Hello, good morning.
Good. Here it's good afternoon, but good morning, Hano. How is that side?
I'm good. I'm good. How are you? How's the event going?
The event is going on well. We have had Thomas in the morning, and he did us well indeed.
Great. Good to hear that.
Yeah. So we are about to call our first presenter, but we had some 3 presenters from the last challenge. So the paint will come, but we had a lot of applications from the leather. So we are going to first finish with those, then we'll switch officially to the paint sector. But also your insight can be brought up here because general chemistry concepts.
Sure.
Okay, thank you, Hannah.
Awesome. Certainly.
Kansai plus Koniguana Limited. I'm Java Stuart Michael. Still. Java Stuart Michael. I'm Java Stuart Michael, a research and development chemist at Kansai plus Koniguana Limited. Good afternoon, everyone. One of the most influential German philosophers, Friedrich Nietzsche, said that the best weapon against an enemy is another enemy. And we are all aware of the phrase that, that goes, the enemy of my enemy is my friend. So, what if the very waste from leather tanneries, the discarded trimmings from the animal hides and skins could hold a key in solving one of the biggest environmental challenge, that is plastic pollution. In transforming this overlooked byproduct into gelatin, we are creating an innovative solution, and we are manufacturing biodegradable plastic bags that could rival the existence of the polythene bags And in that being, that could rival the existence of the polythene bags in utility, whereas being kinder to the planet. Could this really be the most sustainable solution we have been looking for? Let's dwell into that. So, in my introduction, there are 3 key terms. Yeah, 1, I'm talking about the leather tanneries, and I'm talking about the gelatin, and thirdly, I'm talking about the pale trimmings. So, what are leather tanneries? Leather tanneries, these are sectors in which animal hides and skins are being used as key raw materials to obtain leather-related products. So, the gelatin. We are obtaining this gelatin. It's from this gelatin that we are going to obtain the biodegradable products, those packaging products. Okay, so let's define our gelatin. Our gelatin is a protein in nature substance obtained from collagen. Of course, the next question will be what collagen is. Define collagen. So collagen is a protein that acts as the main structure component in the skin, bones, tendons, ligaments. It provides the strength and elasticity. So we obtain the gelatin from the collagen. The main reason why that is very simple to do is because gelatin is soluble in warm water, whereas the collagen is insoluble in warm water. Thus, the extraction from collagen is very easy. So, the collagen itself is obtained from lime leather pale trimmings. Lime leather pale trimmings are offcuts or waste materials generated during the leather tanning process, and they come from the lime-treated hides or skins. Some of the characteristics of these trimmings, they have a high collagen content. We have just seen from the previous slide that collagen is the main structure component. In other words, it's right to say that these trimmings, they contain a very high content of the collagen. In addition to that, they contain too much of the residue lime, and lastly, the non-collagenous materials. What's the current fate of these trimmings? What are the tanning industries doing? Some of the industries, this is from literature, some of the industries go on to just dispose in landfills. In other words, that goes on to create an environmental problem. They cause environmental pollution. Same with incineration or stroke burning. Still, it causes the environmental pollution. Thirdly, waste accumulation in leather production facilities. Now, some of the industries may just try to accumulate this waste. In other words, they just want to dispose it off at once. So, in the long run, it becomes costly. They will call in a company that can dispose of the waste, and being costly to the company itself. And lastly, some industries are really doing the reuse, but still at a small scale. Yeah, from the challenges associated with lime leather pale trimmings, from the current fate, we have seen that the disposal and the incineration, they lead to environmental pollution. The too much access or too much exposure to those trimmings, we get health issues. In other words, you inhale in dangerous chemicals. And lastly, we have seen that the accumulation of that waste, the continuous accumulation of the waste, leads to economic implications. Yeah, the block diagram representing the manufacturing process of gelatin. We first collect all the lime leather pale trimmings. Then we pre-treat. I'm pre-treating with acetic acid. Why? Acetic acid is a weak acid. So the reason why I'm pre-treating with acetic acid is because I want to remove the lime that is existing. So the acetic acid will react with the calcium hydroxide to form the calcium ethanoate and water. I go on to deneutralization. Now here I'll be adding a weak base too. I'm dealing with weak acids and weak bases. So I will add in a weak base. Can go with sodium bicarbonate so as to maintain a pH of 6.5 to 7.5. Then we do the acidic hydrolysis. Still, the acidic hydrolysis, I'll go with the acetic acid. The reason why I'm doing the acidic hydrolysis, it's because I want to separate the collagen from the non-collagenous materials. In other words, this hydrolysis, I introduce the acetic acid in presence of warm water. So we shall get the insoluble collagen floating, whereas the non-collagenous materials sinking down where we are treating from. Then we can, in fact, this acidic hydrolysis, that's where we obtain the collagen. So we shall just extract the collagen, which is insoluble in the warm water. Then gelatin is obtained from collagen. I pre-treat. I still repeat the process. I pre-treat and neutralize acetic acid and sodium bicarbonate. I obtain the gelatin. Now, for the process of obtaining the gelatin, we just do the partial acidic hydrolysis. Why? Partial acidic hydrolysis gives us the gelatin with the desired properties. In other words, the moment we do full hydrolysis, we shall just decompose all the proteins present into amino acids and peptides. But we are more interested in obtaining the gelatin. Then from the gelatin, we go to the bioplastic production. So some additives are added in there. Yeah, you can increase the flexibility, you can increase the strength though you just add those additives to the gelatin and you get those bioplastic products or bioplastic bags. So one of my byproducts during the production of gelatin is the non-collagenous substances. Remember, we extracted collagen from them. So, but we have to put these non-collagenous substances to use. So, one, we can do the biofertilizer production. Yeah, these organic byproducts can be used to enrich the soil, improving its texture and nutrient content. But before even doing these applications, we can first treat the non-collagenous substances with activated carbon. Yeah, it's very green and it can help reduce the contaminants, the chemicals within the non-collagenous substances. So we can go in for fertilizer production, leather board production. Leather board production helps to reduce the over-reliance on wood. Yeah, of recent deforestation has been to a very high level. So it's okay. Yeah, then we have biofuels. In other words, we do the anaerobic digestion. We obtain the methane gas. It can be used to run our machines as well as it can be sold to earn money. Then animal feeds. We can, as well as biofertilizer production, they are enriched in protein. So we need to expose them. We can expose them to our livestock, and they will be rich in proteins. So, what are the benefits of this project? One, we are making products that are biodegradable. In other words, they can decompose. If after use, they can be decomposed by the microorganisms. Two, we are doing renewable energy generation. We have just explained that we can obtain the biogas. Three, it's non-toxic, and anything which is non-toxic is user-friendly. And lastly, it's sustainable. We can, the more the trimmings exist, the more we can do the more we can obtain the biodegradable packaging products, and the more it will be sustainable. So it won't be harmful in the nearby future or the later future. The overall comparison, polythene packaging and gelatin-based packaging. Yeah, the polythenes, for now, they are at a lower cost. One, it's because it has been there for ages. But the more if we are to start to implement this gelatin-based packaging, trust me, at first it will be very high, but with time, it will get to a very low cost. Two, we have seen the sustainability. It's very sustainable, the gelatin-based packaging, whereas polythene packaging, it's not sustainable because its biodegradability is very, very bad. Toxicity, it's very less toxic compared to the polyethylene packaging. Availability, since it's just an upcoming technology, it's not very much common. But with time, if we are to start implementing these technologies, yeah, its availability to increase with time. So, what are the benefits of reusing these lime leather pearl trimmings? Just a recap. We are reducing in health-related problems. We are being sustainable in the environment, economic benefits, and it is really giving us a chance to be innovative in bioplastics that are biodegradable and sustainable. In my conclusion, transforming lime leather pearl trimmings into sustainable biodegradable products is just not an idea, but a reality we can embrace. By harnessing the power of gelatin, it helps us to create innovative solutions. In other words, reducing the existing waste and also providing alternative solutions for the greener and cleaner world. So it's high time we rethink how we view waste and realize its true meaning in creating a cleaner and greener world. Thank you.
We are going to ask Hano if you have any question or comment about that. Any inquiry, clarification?
I guess I'm just asking, how do you usually have feedback for every presentation or no? Did you hear that?
Pardon.
I guess I'm asking, do you generally have feedback for every presenter or no? Just how have you done it so far?
What we do is we get feedback from all the judges, to the panel, from the reaction from the judges, and then after we address all the concerns at a go, after everyone has given in their inquiries or comments.
Okay, I can be brief. I think that was very nice. The one thing that I would have liked to see was what does the product look like, and what do you think it could be used for? What kinds of applications?
Okay, thank you. He will address that.
Thank you, Mtiaba, for that nice presentation. Have you done some preliminary work on this? Or you are suggesting? Okay. Oh, because I was wondering, from collagen, which is a poly what? A polyamide. Then it is changing into a plastic. I wonder. But that is just nomenclature, okay? You can change the nomenclature later. Because it is changing into a bioplastic, from a polyamide, from a protein to a plastic. I had challenges, but it's a good project. Thank you.
Thank you, Stuart. You go to there's a slide where you're comparing that one there. I want to know the cost, polythene packaging, gelatin-based packaging. I want to know exactly where we are applying this kind of packaging specific. And given that you see you are labeled Plascon, are you providing a solution to Plascon? Because it would be such a mess. If I were a CEO of Plascon, I would call you unserious if you're looking for solutions to some other people and I package my paint and you're not providing a solution to me. It would be very not comfortable for me. Are you providing solution to Plascon? Are there any factors of this, beneficiaries of this? Then, in terms of properties, what are the key differences in the plastic, the PE, and then the one you want to get from these gelatin, the bioplastics? The kind of properties that then would, allow Plascon or any other packaging company like this, WAVA, that is if you can make this. That's why I think our colleague is asking, how does it look like? Who uses it? And so on. So just throw light on those. And then the cost. Is that cost the cost of the process or the cost of the product? Because we need to understand. The cost of the product can be high because you are completely non-lean, and therefore you transfer your hidden factory to the consumer. But if you're lean, you will produce a good product at a low cost, which will give you the privilege to sell it at a low price because you didn't incur a lot making it. But if you have two factories, the real factory and the hidden one, you transfer the cost to me, the consumer, and then you'll say the cost of the product is high. So we need to also to understand. Because if someone is going to fund, they need to understand. Thank you.
Okay, thank you, Stuart, for the presentation. I just wanted to know the waste, the byproduct that are going to be produced, and how are you going to manage them? And still knowing that after turning, you still have the chromiums. I don't know, how are you going to address it? It still remains there. Everybody in this, they don't really mention how they are going to handle that.
Thank you, Stuart. I wanted to know, in your presentation, the project has 3 result-based aspects. You have the polythene bags, you have the fertilizers, and you have the biogas. Where do you differentiate yourself from the rest of the presenters? What is your niche? What's your key target out of this innovation? Are you targeting to innovate for all the 3 aspects, or they will be covered by your innovation?
Thank you, Stuart. You talked of using activated carbon, I think, to treat the byproduct when you are producing the biofertilizer. How do you plan to manage the activated carbon after you have treated the waste? Secondly, the safety of the bioplastics you are proposing to generate. How certain are we that they are good for any packaging? What is the intended use? Thank you.
Thank you very much for the questions. let me start tackling some of the questions. One of the questions was, what's the main target of this project? The main target of this project is we want to rival the existing polythene bags by introducing the gelatin-based packaging bags. In other words, the polythene bags are more harmful to the environment than the incoming gelatin-based packaging bags. So the main target is to manufacture gelatin-based packaging bags, but the production of biogas, the biofertilizers, and animal feeds, that is just, we are obtaining those three from the bioproducts, which is the non-collagenous materials. But the main target is to obtain the gelatin-based packaging bags from the collagen. I was asked if Plascon is a beneficiary. The reality is Plascon is not a beneficiary, because the way Plascon packages its products, it doesn't use polythene bags. Just uses real-time plastics for the water-based and metals for the solvent-based. So it is not using polythene bags. In other words, this project is not tackling it directly. Then the cost, I was asked if it is the cost of the product or the cost of the project. Since it's just an incoming technology, I would say that the cost of the product will be very high. But taking mind of the products from the byproducts, and also taking mind of the products that come from the byproducts, the fertilizer, all those, they can come and cover up the costs that can be incurred in the production of this gelatin-based packaging. In other words, in the long run, the cost will get to the lower side. I was asked about the chromium. Yeah, about the chromium. I talked about activated carbon. It may not come and take away all the chromium, but will reduce the risks of that chromium. Then applications of gelatin-based these are packaging bags. We can apply in the medicals. It can be used for medical applications. Those are packagings, the food pharmaceuticals, the food processing industries. It's all about packaging. Anywhere where we can do, anywhere where we can replace the polythenes, we can apply the gelatin-based packaging. And lastly, was asked how we obtain the gelatin from collagen. That's very easy, as it was on my second slide where I say that the collagen is very insoluble in warm water, and the gelatin is soluble. In other words, the extraction is very, very easy, as one of them will be insoluble and the soluble part will be obtained as the gelatin. Thank you.
Thank you for the comments. Let's go to another presenter. That's Robert. And okay, press this for back, and this is for forward.
Good afternoon. My name is Robert Gazette. Me and my team have come up with a project to convert the leather tannery waste into a high quality glue. Since we know that the waste from tannery industries comprised to about 75%, which is not being reused, we have come up with this project to convert this waste into glue. Looking at the problem statement, most of the glue we have in the market it's petroleum based, which is non-biodegradable, and it poses a lot of hazardous chemicals like Vox, benzene, formaldehyde that is dangerous to the environment and then to health. So because of that, we have developed an eco-friendly adhesive glue from this waste that is generated from the tannery. So we convert this leather tannery waste into glue, which of course has a circular economy solution, and it addresses problems of adhesives. And we know that most of the products we have on market, especially the packaging industries, use a lot of paper as packaging, and most of these papers, to make a packaging material, they have to use glue to make that product. Then also in the woodworking industry, most of the products that are made from wood, they need glue, especially the chairs, so many. That's where the application of glue comes from, and we can easily be able to mitigate the environmental impact which could have been caused by the excess waste from the leather tannery industries. So the value proposition of this is specifically the production of high quality glue, which outcompetes the petroleum based glue on the market. Because it is non-toxic, does not involve any chemical, it becomes eco-friendly to the environment, and also the economy principles of turning waste into the valuable resource. The resources, it reduces waste resource treatment by converting this waste into glue. If we look at the technology overview, it's not a very complicated process. First of all, you need to gather this waste from the tannery. You wash and clean them with water. So in the process, we remember that they are both treated with chrome, and those that of course are not treated. But after cleaning this, you need to develop a process which will be able to remove the chrome. It's not indicated here, but we treat this already cleaned waste, the offcuts, with about 10% hydrochloric acid, which is going to give us a salt, sodium chloride, which is soluble in water, before the other process of shredding and grinding. But remember, this product, this waste, which is already having the solution of sodium chloride, the soluble chromium chloride, is still can be converted back. It can be reused in the process of through turning liquor recovery system, whereby at the end of the day, you are not going to dispose this chrome into the environment, which can cause more harm, but it can be rather reconverted back and can be reused by the leather tanning industry, such that it reduces on the loss especially with that. So after that, you have to shred. You grind them into smaller particles, pieces, so that you increase on the surface area for extraction. Because our main aim right now is to get collagen that we are going to convert into gelatin. So you soak in water often for some time just to make sure that it's easy for extraction. So after the process of soaking, grinding, then you pass it through enzymatic hydrolysis using collagen as an enzyme, where you are going to get the peptides and amino acids that will give you the gelatin that you are going to use to produce the glue. So in the extraction process, this process takes about 12 hours, but you treat it at ideal temperature of 80 to 90 when you keep adjusting the pH between 5 to 7. And you have to concentrate, simply removing excess water that is in the already ground product. You do the filtration. That is when you're going to purify, because after concentrating, there are still other impurities that are embedded in there. So you need to do the filtration, or you can do ion exchange or precipitation as one of the methods that you will employ to do the purification, depending on the technology that is available on ground. These are just the methods of purification, but you will use, we can use the one that we know is available. So after purification, then we can do drying, freeze drying, spray drying of the product, just to concentrate. So after getting the purification, we need to do modification of the gelatin. So this modification of the gelatin, particularly, it will be able to help you to improve the properties of the gelatin. We can use plasticizers. These plasticizers, they improve on the flexibility of the glue. And then do cross-linking agent, which enhances the strength and durability of the glue. Excuse me. Then we can add thickeners to increase the viscosity. Most of these thickeners, we can use starch, which is readily available from our raw materials like cassava or maybe maize. So this is the summary of the process. From collection and the preparation of the waste, you go to shredding, that is grinding into finer particles, pieces, just as I said, to increase on the surface area of extraction. Then you soak in water. Now, soaking in water simply helps to, thank you. It helps to break down the collagen bonds. Then we do the enzymatic hydrolysis, extract, concentrate, purify, and then you modify. Looking at the market size, right now as we talk, we expect, we are seeing it's about 68.88 billion. But if we do the projection in the next maybe up to around 2028, it's about 87 billion. Looking at the market opportunity, it has vast potential in industries like wood processing and crafts and so on, because that is where we're heading to. Then there's a growing demand for non-toxic, environmental friendly adhesives, which cannot affect the environment, even the health. Then the competitive advantage, first of all, it is non-toxic. It does not affect the user, eco-friendly. It's biodegradable because we are not using any other synthetic reagents in the process of production. Cost effective. It's not the technology that is employed here is not very expensive, because we are not using products that need more refining. It's just it's actually a physical transformation of the waste into a biodegradable glue. So, and the business model, we converting this leather into waste and the revenue streams, because we are collecting this from different companies, or maybe when you have an MOU with one of the companies, you'll be able to get these raw materials from them. And then when you sell the glue to public, to these other industries, wood, crafts, and so on, it will earn, you'll be able to earn a capital or revenue from the use of what? Of the glue. So we came up with this project, and we believe that because of its stability, its convenience of production, glue being one of those, in the market we have the glue which is which is not biodegradable, but this coming up with this will be able to help to prevent the issue of doing away with our environment. It's eco-friendly, does not affect any. It doesn't affect any green chemistry principles. So basically, that is how the whole process goes. And thank you for listening.
Thank you for that presentation. So as our procedure has always been, we'll have an inquiry, compliments or questions. And I will request Hano, do you have any question, any inquiry, or clarification you're seeking? Thank you.
Thank you. Can you hear me? Do you hear me now?
Yes, we do.
Great. Thank you for that presentation. I only have one question. How have you tried how well this glue works and how long it lasts for, especially if you're talking about furniture, for example?
It is noted.
Thank you.
Have you heard? Okay, yeah, it's applications. Thank you.
Well, thank you, Robert. Now, this question actually, I'm asking you, but it goes again to all of us who have presented and those who are yet to present. The observation is, your talk is chemistry, 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 which is good because it is a chemical, you are dealing with chemical processes. But you're pitching ideas, and ideas are beyond chemistry, okay? They are way beyond chemistry. Chemistry is what will be happening inside machinery and equipment. It won't happen in space, will it? Not at all. So while we go ahead, let's give some indicative machinery and equipment involved in these processes. Simple touch on some cost estimates for your target products. What are the indicative production rates? Maybe if I'm going to produce glue, how much glue do you want to produce? We want to know that, because if when you talk about impacting the economy, you're not going to go produce 1 kg and you're going to impact anyone. So we need to hear those, because you're pitching, and where I come from, I want to hear those. I'm going to produce so many kilograms of glue, and like he was asking, of this kind of quality which can be a substitute to the one we import or the one we make from any other source. Such kind of, that goes to all of us who have presented and those who are yet to present. To estimate, you don't need to be accurate at all at this moment, because you're pitching cost indications, some rough machinery and equipment that is going to be involved, production rates, and so on. Thank you.
Thank you very much, Robert.
Mine is to do with, have you done preliminary studies on this glue? Or because any glue has those properties of remaining runny. You have to ensure it remains runny during its shelf time or before opening. Have you tried to check if you do the polymerization, the preparation of the pre-polymer, because you have to make it a pre-polymer before it serves its function of being a glue. Have you tried to work out the conditions for it to remain a pre-polymer and therefore runny before hardening? Thank you.
Thank you, Robert, for that innovation. In one of the slides, you convinced us that your process follows regulatory trends. But I realize that you are using a lot of resources. There's a lot of water use, energy use, because the extraction process involves heating and purification. Then there is freezing. So the material use is really, in my opinion, is high. Have you tried to conduct a material balance of the process? Secondly, in your processes, I don't see you characterizing the glue to follow on my colleague's submission. I thought you would wish to have characterized the glue so that you can tell us the intended purpose, whether it is wood to wood, paper to paper, and so on. Thank you.
Thank you for those questions. I think I will start by the last. Characterizing the glue, first of all, this glue, the intention of this glue is basically to do with the craft work, the woodworking in the wood world. So this glue production will focus on that market in the woodworking, in paper producing industries for packaging, and then also the craft work. So that is the purpose of the production of this glue. That is how I can characterize it. This specifically will... Okay, thank you. That is going to be taken into consideration. I go back to the regulatory trends of this of the product. First of all, it's going to be a product which will not go to the market until it meets the required standards. And required standards, I mean, after producing this, we'll need to look at, we have to do a laboratory test of the characteristics of the glue. Basically, we look at the moisture, the viscosity, the bond strength or the shear strength, and the setting properties, and then the shelf life. That is going to be a test which has to be done in the laboratory to confirm the quality and a certification of the product. So, which will have to be done when the production is, we shall have something to be, because every product that comes has to go through the process before it is out. And this is an initiative that will lead to that. Then I think there was a question about the preliminary studies, which falls under testing this glue under the standard. I believe there is a standard for adhesives, which we shall follow to come up with a product. I think the online question was about the widely application of the product. We all know that right now we are running away from synthetic packaging materials. which we have failed to fight up to today. We still have it on market. But if we embrace this initiative and we come up with a product that can be able to combine and be compatible with a biodegradable wood and paper products, then we will be able to kick away the non-biodegradable caveras that we have in the market. And it is happening, but because things like glue, which are actually one of the most components used in making those biodegradable packaging materials, are not available, and if they are there, they are not biodegradable. It is the cause of us not living this, and it is greatly affecting our environment with plastics and caveras that have been disposed everywhere. And then I think I had about the population, I mean the production cost. Yes, this is the initiative we are having. Right now I cannot tell you the production cost, but this technology from the literature is something that can easily be embraced, and it cannot cost that much that we are not going to accommodate. Thank you.
Let's have Swabra, our second last, before we switch to paint.
So for the next, I just press on. Okay. Protocol observed. Ladies and gentlemen, good afternoon. My name is Munira Swabra. I'm going to address the challenge of leather pellet trimmings. There are solid waste that are got from tanneries after the liming process, because in the question, in the challenge was saying develop innovative solutions for the lime leather pellet trimmings. From literature, it is said that very little of the leather is being used, and 85% or 75% is being disposed of, which is the lime leather pellet trimmings, and they're disposed of to the environment. And as we know, these lime leather pellet trimmings, they have impurities and they can contaminate the environment. So the problem statement is when people who have visited the abattoir, where they slaughter cows, animals, when they dispose of the leather, that place really stinks. It really smells so badly. So there is need for us to find solutions in order to address that. And in the other way, we can talk about the tanneries, because the solid waste is almost the same. So the lime leather pellet trimmings, they are solid waste that are cut off from the leather. And since in Uganda we are facing solid waste management as a problem, ever since the landfills in Chitezi got filled up, there is need to get innovative solutions whereby we reuse waste. So for me, I'm not going to talk about the leather fiber production, because earlier on in what Saleh said, I don't think it is feasible enough. So I'm going to talk about composting. Composting is the decomposition of organic materials. Here I'm going to be talking about the lime leather pellet trimmings into nutrient-rich soil. Let me say soil. In the composting process, here we collect the lime leather pelt trimmings from the tanneries. We can sort them and maybe we can cut them into small pieces. Here, when you cut them into small pieces, it's going to enable a faster rate of the decomposition of the lime leather pelt trimmings during the decomposition process. I didn't put the details, so I'm going to be speaking more of the things. So we are going to get the fact that lime leather pelt trimmings are more rich in nitrogen. We are going to get carbon, whereby the sources of carbon are going to be wood, all those brown materials, maybe like from trees, especially maybe those trees that maybe like fall down, and so that in order to get the manure, we need to get a third of the lime leather pelt trimmings, because we cannot use a lot of the nitrogen in the composting, because if you use a lot of the nitrogen in the composting, it is going to lead to the production of ammonia, and ammonia is going to increase, is going to lead maybe to the a source of bad odor. So we are going to use 2/3 of the carbon and 1/3 of the nitrogen. Maybe you can just weigh for the ratios in order to be exact. And we're going to use 2/3 of the carbon, because carbon is going to be a source of nutrient to the microbial organisms. Yes, so maybe we get a pit, we put there a third of the lime leather pelt trimmings that are cut. Then we also put the 2/3 of the carbon, and we're going to you can cover. Then you check on them. Maybe you can use there is an article that I read about, and then whereby they're using vermicomposting, whereby they're using earthworms. So you can also use earthworms if at all you have the money to increase on the decomposition process, maybe like the decomposition to be faster, because this process, as the way I read it, it takes 90 days. So you have to make sure that you maintain the oxygen, the moisture, optimal temperature of 50 to 60 degrees Celsius, and then you have to turn. You have to make sure that you turn them. Maybe you get something to stir so that the reaction is even. And you have to make sure that there is, if at all you see when the moisture is a little bit low, you can add in water in order to increase on the decomposition process. Then you have to wait till the 90 days get done. I think that's when the curing, and then that is almost like the maturing of the compost. Then it can be used to the crops. I chose composting because Uganda is an agriculture country, and instead of using artificial fertilizers, we can use compost. Someone can do it at home, other than using artificial fertilizers. You invest that money in something else. And here I chose composting is good compared to the artificial fertilizers, because it has little or no effect to the soil. People and farmers who usually use artificial fertilizers, they have effect on the soil. These artificial fertilizers can make the soil barren. So this is the value proposition of composting. And maybe the challenge that I can say about composting is that maybe people are really unaware of how to make it. So we have to create awareness to the farmers to use things that are sustainable, because some people know that maybe manure is really, really good, but then they just apply it without maybe following the procedure. Yes. And the other innovative solution is glue. Since lime leather pelt trimmings contain proteins, contain collagen, and collagen is a protein, so it can be good for making glue. And glue is an adhesive. Adhesives are substances that bind together materials, and then the process is as follows. The preparation stage whereby you get the lime leather pelt trimmings, you cut them, then you soak them in order to allow the collagen to be exposed. Then you add in acetic acid. You get off the glue, like the gelatin that is on. Then when you get the gelatin that is on, you put it in evaporation kettles, whereby you reduce the amount of water that is in the gelatin, and then after this is done at 100 degrees Celsius. Then after the concentration, you dry and then you package. And all these things, I read them, and then it's a feasible process. I'm not going to give you maybe like all the details, but what I know, it is a feasible process, and it can be used as an innovative solution for the reuse of lime leather pelt trimmings. Thank you.
Comments from the jury? Hano, any comments?
Thank you for that presentation. I would love to learn a little more about the composting itself. How quickly does the leather turn into a material that looks more like compost or soil?
That is noted.
Thank you.
I think I can combine it to his. If I look at 90 days, you have already answered, I think, his question. You're talking of composting that takes 90 days. But if I'm looking at the source of the trimmings, production versus the 90 days, how feasible is it that you use 90 days to compost and then the volume is accumulating? Will you be solving a problem? Or will you be providing a solution for the problem? Because the production compared to the time for composting is so big. I don't know whether you have visualized my question. Thank you.
Swabra, this compost you tend to produce, what is the intended purpose? Is it for agriculture use? Yeah. Have you thought of considering its quality in terms of chromium content, for example? Because you've not explained to us how you intend to remove it, how to intend to remove chromium. And the process, you talked of supplying oxygen to the system. How do you intend to do that?
Thank you very much, Swabra. Mine is to do with you need to make choices on whether to use the microorganisms or the earthworms, or there are some fungi that decompose the wood, that work on the cellulose. You could also consider such to be part of the composite. Thank you.
Thank you, Swabra. Just for me, clarify exactly which product, because I see glue, see compost, and leather, so let's be clear about the product. Then how do you, if it's glue, how do you differ from Robert? He's also talking about high quality glue. And if it is glue, then again, we need to understand
because he was talking about where exactly this glue is going to be used, the wood and so on. Are we using the same glue for wood, or is it for any other purpose? So let's be clear. Let's pitch. Pitching, you have to be very clear. Okay.
Thank you for the presentation. I just wanted a clarification on there's a point you talked about carbon addition or carbon using trees. Just give us some more details of that. Yeah.
Thank you so much. For me, you asked about the time, and since it's just a solution that I've not really read more about, I've read more about it, but I don't know how feasible it is. I think that the fact that it really addresses the use of fertilizers, I think it's okay. Because when you're using artificial fertilizers, there are negative effects that they cause to the soil. For me, in my perspective, that time, I'm going to maybe to look for maybe a feasible method that can maybe reduce on that time in order for the compost to be used. That is why the first person.
Sobra,
Yeah?
you could think of batches. You get it? The way they produce poultry chicks. These are 2 weeks. These are you can have the 90 days, but you have batches. Yes, series in a conveyor belt.
Thank you so much. And the person that asked about the chromium content, I hadn't looked about it because we're talking about the lime leather pole trimming. So for me as a person, I didn't see the chromium coming in because I was looking at the lime leather pole trimmings immediately after the liming process. Maybe I'll just look for solutions whereby that can deal with the chromium. And then the aeration. Someone, they asked me about the aeration. You can, since it's a pit, you can open it, or maybe you can put a vent to allow in oxygen for the microorganisms, since we are dealing with aerobic, with an aerobic process for the microorganisms. And for me as a person, I didn't know that there was someone that was going to present about glue. Yes, I didn't know. These were my innovative solutions. And the glue, what I read about glue, is almost what he said, binding of materials like books, wood, textile materials, because they asked me of what the glue is going to be used for. And what I read about it is that it is really, really good for the, considering the characteristics of the standard glue and the one that was made when I read the article. And then the carbonaceous materials, I gave an example of wood because wood is a source of carbon. I think I've answered your question. Thank you.
Hey Bagonza, are you on? Can you unmute? Can you share your screen?
All right.
It's your time. Okay. So Bagonza will come after, because it seems. First wait. Yeah. Dear Bagonza, it's your time. Can you start sharing?
Well, is the screen visible?
Yeah, we can see you, but we are not seeing the document. Share the screen again. Okay, I think we are going to go with the physical. Then after, we'll go back to her. But she was really... No, this is the sister. Yeah. So people are wondering, oh, we are seeing someone here and there. So it's the sister who's representing her physically. So we'll cross to the paint industry. And we'll start with the... Mutiaba. With the greenie. Tanish, it's your time, sir. So, Hannah, we are crossing to the paint industry, and we will have her at the last applicant later.
Good afternoon, everyone. Yeah, now this is where Plascon is coming in. Okay, today we delve into a pressing environmental challenge, the emissions of volatile organic solvents from alkali-based varnishes, which significantly contribute to air pollution and health risks. In response, substituting a green-based varnish onto the alkali-based varnish explores a transformative approach to sustainability in the coating industry. Hear me out as I unpack the science, innovation, and benefits behind this project. Yeah, in my introduction, I've talked about the alkali-based varnishes. These are its composition. It's made from long oil alkali resins, white spirit, and metal dryers. Yeah, these resins are most of the long oil alkali resins. They are about 70% non-volatile. In other words, the 30% still contributes to the volatile substances. Yeah, the key features. They are highly durable, quick drying, and excellent adhesion. Common uses, in the paint, in the art paintings, in the coating industries. Challenges, we have talked about the environmental pollution, health risks, and the high volatile content that is being released to the atmosphere. You may be wondering why I chose varnish. It's because varnish takes a biggest percentage of the resin and white spirit compared to the pigmented products in the coating industry. So, why is there a need to move to a greener side? Why move to greener varnishes? One, we are looking to advance in non-toxicity. Yeah, we need a non-toxic, a sustainable, a user-friendly, and biodegradable product. In other words, we need a greener-based varnish in which we are not going to pollute the environment and we are not going to cause any more health risks. And we also need a product in which the raw materials are readily available. Yeah, what goes into these greener varnishes? Yeah, initially I say that for the alkyd-based varnishes, we have the long oil alkyd resin, the white spirit, and the metal dryers. Now, what goes into the greener varnishes? We are looking at Canauba wax, or we can use Canauba wax. It's a natural wax from palm trees. Or we can use sunflower wax, which we can also obtain from sunflower seeds. D-limonene, yeah, this is a terpene and a plant-derived solvent from citrus fruits. It's biodegradable and less toxic. Let me first dwell into that for a little bit. In fact, this was my final year project, extraction of D-limonene. This is we extract this D-limonene from the peels of the citrus fruit. In other words, after obtaining, you get your fruit, you peel off, you get the peels, and you extract the D-limonene. After extraction, you get around 3 products. One, you get the D-limonene itself, you get the hydrosol, and also you get the remaining peels after extraction. The D-limonene can act as an essential oil itself, or it can be used for this purpose. But besides this purpose, it can act as an essential oil. Secondly, the hydrosol. It's just water containing D-limonene properties. It's less concentrated compared to the D-limonene itself. So the hydrosol can be used in the cosmetic industry, in the perfumery industries. Yeah, then the remaining peels, they can be processed further into fertilizers. So in other words, during this embracing of this greener varnish, I would think of starting to first extract the D-limonene itself, because there are various opportunities within itself. As we can obtain the D-limonene, but we can still obtain, we can still supply the hydrosol, the fertilizers, and the D-limonene to other sectors. Yeah, thirdly, the linseed oil. It's a renewable energy with good drying properties. Yeah, this one can obtain from flax, whereas the sunflower can be obtained from the sunflower trees, respectively. Yeah. Then we have the colophony, or the rosin. It's just a resin from pine trees used to improve adhesion. Adhesion is very, very important in the coating industry. It will be very embarrassing if you apply your paint and realize you are moving with the paint. The moment you step on that part and you move with that part, it will be very embarrassing. So adhesion is a very key factor. Then citrus acid, a naturally occurring acid to adjust the pH. Then soy lecithin. This is very important because during the manufacture of this product, we are containing 2 phases. That's the oil phase and the liquid phase. But we want to have both of them. So we want to have both of them to be uniform. So we shall need an emulsifier to contain both. In other words, to bring about the stability of the 2 phases. Then we have water. Water, its use is to help us in adjusting the viscosity. That's one. And to help in making the product appear cheap. A simple block diagram for the manufacture of the greener-based varnish. Yeah, I talked about the wax. Now this wax will be in solid form. So there will be need of melting it, obtaining temperatures about 70 to 90 degrees Celsius. After melting the wax, we add in the colophony, which is responsible for the adhesion. Then we add the oil, we mix, we add the D-limonene solvent. This solvent is responsible of making just a solvent for this oil phase. We emulsify, we add water, and then we get our product. How to transition to greener varnishes? There will be need of research and development. In other words, we need to invest in formulating new high-performance greener varnishes. So the role of the research and development will be vital in this production. Then supply chain adjustments. Yeah, we need to get secure, reliable suppliers for these eco-friendly ingredients. And there are very many in Uganda here. We can contact the oil producing companies, the cooking oil producing companies, the Bidiko and Mukwano and Sa. Consumer education. Highlight the benefits of the greener varnish in marketing. In other words, we need to educate the consumers on the health risks and environmental pollution that is being caused by the alkyd-based varnishes. And we need to show them the need of converting to greener varnishes. Then, lastly, a compliance with the regulation. Ensure the product meets environmental standards and certifications. Performance comparison. Alkyd versus greener varnish. Drying time. Drying time is a very key factor. In other words, alkyds generally dry faster due to presence of the metal dryers. But this drying can still be adjusted. The drying time can still be adjusted in the greener varnishes due to the presence of the oils, the linseed, stroke sunflower oil. 2, durability. Alkyds have better long-term durability in harsh environments, but greener varnishes can be made with additives to improve the performance. 3, the appearance. Both types provide high gloss and smooth finishes, so we shouldn't be worried about the shining properties. Then the cost comparison. Cost comparison of the final product. The alkyd varnishes, lower raw material cost due to the use of petroleum-based solvents. Greener varnishes, higher cost due to the use of natural and renewable ingredients, for example, the oils and the D-limonene. Then the overall cost considerations. While greener varnishes may be more expensive, they are gaining traction in premium and eco-conscious markets. In other words, the world is transiting from the alkyd-based to the greener side of it. Then comparison of alkyd-based varnishes and greener-based varnishes. The cost for, in the beginning, the cost of the greener-based varnish may be high. Yeah. But after securing the suppliers, that's one. 2, talking about the extraction of the D-limonene itself. If we try to secure that as the company itself, we can try to minimize the costs. In other words, in the long run, the cost of the final greener-based varnish will be cheap compared to at first when it's being produced the first time. Sustainability, it's very sustainable. In other words, it's not going to cause further problems when it's placed on the market. Toxicity, very low, it's less toxic, very highly biodegradable. When it can decompose, when left, then availability of raw materials, it's high. In other words, here, for the greener-based varnishes, we are talking about obtaining the raw materials from the natural sources, the palm trees, the palm trees, the pine, the citrus fruits. So, what is the future of these varnishes? Sustainability in coatings. The future lies in reducing the environmental footprint of varnishes while maintaining the performance. 2. Consumer demand. Rising demand for eco-friendly products will drive innovation. And lastly, long-term benefits. Lower regulatory risk, better health outcomes, and market differentiation. So in conclusion, the transition to greener-based varnish is not merely an environment imperative, but also a strategic step towards innovation and sustainability. Throughout this project, we demonstrate that it is possible to reduce VOCs, the volatile organic components, or solvent, while maintaining the functional integrity of the coating, of the varnish. Let us move forward together, embracing change and paving way for a greener tomorrow. Thank you.
Thank you, Mutiaba. I would like to inquire from Hano. Any question, comment?
Okay. Can you hear me?
Yes, we can.
Great. I wasn't able to see the slides, unfortunately. Maybe in the next one we can figure that out. So I'm going to yield to my judge colleagues who are there in person.
Oh, okay. Sorry, when we were sharing from the other participant, we turned off the sharing option this side. Sorry.
No worries at all. I heard.
Okay. The jury this side.
Oh, I can see it now, yes.
Okay.
Thank you, Mutiaba. Just my question is very simple. Do you have any organizations in Uganda that are embracing these kinds of varnishes? Any that is embracing this transition?
Plascon is about to embrace it.
Okay. Have you presented to the top management of Plascon?
It's a work in progress.
Because all of you, by the way, let me be honest with you. We use our own experiences to guide others. When you have an idea, what do they say? Charity begins where? At home. When I come here and then don't go home and expect a clean home. Don't. If I'm shabby, you look at my house. Young, upcoming innovators. If you work with an organization and you have an idea, start with the organization. Go and pitch to the top management of your organization. I would give you scenarios how I did that when I began career in 2011, and you would be amazed how you would change your life and the country by not leaving your organization, which is also would otherwise embrace a good innovation or a change, and you go to look for strangers. So I urge you, this is good. That's why I was talking about Plascon, because we are Plascon. Yeah? Color your world. If you have this as a good idea, why don't you begin at home and convince, talk to her, go to her. Usually innovation is you have to pitch at the top management. Yes, or you go with her and you sit together and start. If she's the owner, good. But I hope you're getting what I'm saying. Don't leave your house and go to disturb strangers. Begin with your house. Convince your house. I would be very happy right now as a person from STI, Office of the President, if you say, at Plascon, we have embraced this, we are here, and our customers are liking this, I would be very enthused. I would say, wow. Are we clear? So to all of us, if you have something that is relevant. If I have an idea, I wouldn't go to another ministry before where I come from, we are embracing it. I wouldn't. I would first make sure I use my home as an example. Let me give you a scenario. I am a maintenance and reliability engineer and a specialist in that. When I want to preach maintenance and reliability, I use an old car. I have one of my cars is an old 2003 Primo. If you sit in it, you would think this vehicle was made yesterday in Toyota, and they put a wrong number plate, UAR. If you inside, you'll find Android touch screen. You see, this is 2003. Because what am I demonstrating? I am a maintenance and reliability specialist, demonstrating that for any equipment, it has the right time to age, but I can prolong it using the best maintenance practices. Outside, when you see people look, say, you put a wrong number plate, this is UB whatever. I say, no, it is UAR 2003. Then I will demonstrate if I am in that government Ford, it's new, so it should be as good as it is. But what is the demonstration? Begin with your old car. Show people you can make 2003 better than 2023. Yes, and I wish I came with it. I would go and see, you see inside the leather, you see, 2003, how possible? Other people, 2003, they are scrap. Am I lying? Charity begins at home. I can't leave a disorganized house, and I go to a factory to talk about 5S, when my home has no 5S. I would even keep quiet. So I am urging all of us, please, innovation should begin with us, innovating around our houses and around our environment and communities. Then we go and we begin convincing other people. I thank you.
Thank you, Mtiaba, for that good innovation. Just have a few clarifications to make. When you talk of D-limonene, which you are extracting from the peelings, it's not entirely D-limonene. So when you are projecting such information, because when you say D-limonene or essential oil is the major set, okay? D-limonene is just a component. And when you go on the characteristics of essential oils, it is never a single compound. It is a mixture of hundreds of compounds. So you have to be clear that the essential oil from the citrus peelings have a higher concentration of D-limonene. And these are the properties. Otherwise, it's a good project. Thank you.
Thank you. For me, it's quite nice, well presented. I'll patch up with what he's saying. Beyond this, if you bring in a cost element, then that's when I will advise you to go to the head of Plascon. Because those top guys listen to money aspects. The MD will not listen to you about D-limonene. He doesn't know what D-limonene is. But if you bring in a cost element compared to the present production process, you'll be home and dry. And the volumes you are talking about.
Thank you, Stuart. I'll begin from where my colleagues have stopped. The D-limonene, I thought that was your focus. Huh? So, because I'm concerned about the sustainability. Initially in your presentation, it was a mix-up where you are going to get the essential oils from. At one time you said you are concentrating on D-limonene, then the sunflower, then you said you'll get it from guano. So I got a little bit mixed up. This comes to the issue of sustainability. If it is from guano, where we get our oil from, cooking oil, and you're competing now with the food security issue, will that be sustainable? If it is D-limonene from the citrus peels, basically the orange, I believe, will they be sustainable going by the production of oranges within the country. And then you are talking of green vanishes being of higher cost, at a higher cost, as opposed to the alkali vanishes. Is that statement really sharing our concept? Because if they are at a higher cost, as my colleagues have put it, then it will be difficult to convince initially Plascon and then any other would be investor. Thank you.
Thank you, Stuart. That's a good innovation. But I'm wondering, if I'm to look at the vanishes, you manufacture vanishes, and you know vanishes that of high VOCs are there. Why did you select this? That is one. Then, as my colleagues were saying, you'd have looked at the volumes probably that Plascon is making now or producing, or the market need, and then look at the source of your raw materials and whether it will be really sustainable. That is one. That is two. Another thing is that you talked about adjusting the pH of this product, and what is the pH range? Also, the drying time. The drying time vanishes. Actually, the industry here is a fast-paced industry. They want to apply their varnish, and the wood is dry, or the furniture is dry immediately. That, you know, looking at linseed that you are saying will be, I think that's what you said. Linseed will help in the drying. Really, maybe you need to look at the timing, whether that will be good enough for the customers, the time that they will wait, you know, vis-a-vis what they're having now. And some of those high VOC vanishes, they are very fast drying, so probably we need to look into that.
Thank you very much, Mutiava. For me, much as they are firing you so many questions, I'm picking interest in your innovation. One person told us about economic leakage. And I'm going to tell you what economic leakage is. Look at a scenario where a company imports 90% of its raw material to make paint. So you are leaking the economy by taking away the foreign exchange. And when you look at Mutiava's innovation, you see that almost all of his raw materials are locally sourced. So if we are looking at balancing the terms of trade, I commend you on that because you are sourcing all your materials locally. You gave us an example of Kanibawa wax from palm oil, Kalangara, Brabra. So that's a good thing. And then I think they are also firing you questions on market. For my look at this as a niche market, especially if you look at artifacts, I think people who are doing like heritage sites, people who are in ecotourism, those will be your niche markets. UNESCO, which is maintaining heritage sites, this will be your niche markets. So much as it doesn't have, it's not widely accepted, but there is niche in it. And given that you're using local raw materials, actually, I think that's a tick from my side. It may not be scalable now, but I think with development in such an innovation, it can be scalable. And maybe I also want to comment on D-Lemonine, given that I was looking at this platform of sustainable chemistry. There are reports that people have fully understood the structure of D-Lemonine, and they can synthesize it at a lab scale. So it's commercially available. You may not even struggle, but still, I think I was at Soloti Fruit Factory, and these people are struggling with peels of oranges. So I think there is some sense in your thing, and I'm happy about it.
Yeah, all right, thank you very much. Um, uh, yeah, I was asked why I hadn't brought up this idea to Plascon. The fact is, Plascon has very many branches in different countries. There is manufacturing of water-based varnish in some, for example, Plascon, South Africa. There is manufacturing of water-based varnish, but there is use of styrene acrylic binder in that water-based varnish. But my this project is focusing not on the styrene acrylic binder, but on the locally available materials, the wax, the oil, the water, the dilimonene, and the mouse fire. In other words, the more you head to the styrene acrylic binder, the more you will need a deformer, the more you will need a coalescing, the more you will need a surfactant. In other words, we are still contributing to the emission of volatile organic solvents. So the water-based varnishes, Plascon is manufacturing them, but there is need of a more innovative solution. That's why I was still thinking of how to bring it up to the big team. Yeah, but manufacturing of water-based varnishes, it is in place. Just that this is somehow a different angle of tackling the problem. I was asked about obtaining the raw materials. They are locally. We can get them locally. About the cost, I would think where there is water, we can minimize the cost. Where there is water, we can minimize the cost. I haven't delved in to check the cost of each raw material, starting from the alkali-based to the greener-based. But where there is water, we can minimize the cost. The pH range. I'm looking at a pH range of 6.5 to 7.5 because of the presence of water. So it wouldn't be sensible to have a varnish which is either acidic or alkaline, but having water in it. About drying time, water is still going to, okay, linseed oil mixed with water. That drying time is far less compared to linseed oil only. So this water is still going to help us in that drying time. We all know that, okay, I don't know if we all know, but water-based coatings dry faster than solvent-based coatings. So the moment we apply, for example, a silk emulsion, it will dry faster than when we apply a varnish or an enamel, super gloss we get. Then, Dr. Washwa, I'm sorry that I went into more of dilimonene. It's just that it caught my interest because I had done it before. But the project is not all about dilimonene, it's about the greener varnish. And lastly, thank you very much. Thank you very much. Thank you very much. No, there's an individual who had talked about something, but I have forgotten.
Thank you. Thank you for that presentation. Let's have Walakira Bruno for his attempt to fight the volatile organic compounds.
Protocol observed. Good afternoon to everyone. Bruno Olakila is my name, industrial chemistry. My background, I'm a quality control analyst. I've come to present elimination of volatile organic solvents in paints. Organic solvents in paint, there are many. We have got different examples of these solvents. They have effects, that's why we want to eliminate them, both to the environment and also to the human health sector. They affect the human health. First and foremost, I want to introduce what are volatile organic solvents in paint, which we want to eliminate. These chemicals, they are pollutants, in simple terms. They are fumes, which are released on evaporation into the air from the paint. And these solvents, we have examples. For example, we have toluene, we have ethylene, we have the xylene, and some formulations, they use mineral spirits in the production of in the production of paint. We don't need the volatile organic solvents in the paint for different reasons. One, health sector, they are pollutants and they harm the people's health. For example, they cause headache, they cause dizziness, and even the respiratory issues comes along with the pollutant, these pollutants. Second, why we want to eliminate these solvents, environment-wise, they affect the environment. For example, they are contaminant. In the long run, they cause water contamination and also air pollution in the environment. So first and foremost, why do we use these solvents in the formulations? Many paint formulations, they employ these solvents. Reason being, one, the VOCs, they thin the paint. Thinning the paint, they give it a texture for easy application on the surface. That's why they use some of these ethylene, xylene, these VOCs. They enhance paint viscosity and even the flow characteristics when it is applied on the surfaces. Another point is they reduce the drying time of the paint on the surface after its application. It's a solvent. In other words, it's a dissolvent. It dissolves all the additives. For example, the densifiers. It is used to dissolve the emulsifiers and preservatives and even other ingredients used in paints. They are employed because of their sweet smell. We see xylene is having some sweet smell, the odor. So these are reasons why they employ them. But we have the however part. They, as I've said, they cause indoor air pollution. So that's why we are fighting hard to remove or to eliminate or to reduce the VOCs in the paint. So they bring poor quality in the indoor air, causing the health problems, respiratory issues, as I've explained. Another reason why we have to run away from the VOCs, they bring about ozone depletion in the long run, air pollution, water contamination in the environment. Sorry for that. How are we going to reduce the VOCs in the paint? We have got different ways to reduce, to eliminate, or to formulate our paint without or with low concentration of VOCs. One, we can formulate a low VOC formula paint. We can use water as a solvent for additives. We have seen the water-based paint, which is already on the market, because this paint has different types, we have the matte emulsion paint, which is for solvents, and also paint water-based. We can use the bio-based, plant-based dyes when we are making our paint. The dyes which we get from the natural plants for natural ingredients to substitute for the other ethylene, xylene, and other VOCs. Another way is using VOCs absorbing additives or VOCs adsorbing agents. For example, we have the silica gel, we have the zeolites, we have the activated carbon to reduce or to eliminate the VOCs in paint. Yeah, my solution for the problem is going to be adsorption. What is adsorption? Adsorption, I'm looking at white activated carbon to reduce the VOCs in paint. I'm going to employ the white activated carbon as a way or as a solution to reduce or to eliminate VOCs in paint. The white activated carbon, first and foremost, is so effective in adsorbing the volatile organic compounds. It is cheap on the market and easily available. In Uganda, we have a manufacturing company which is making the activated carbon. It is called Western Carbon and Chemicals. It's on 6th Street Industrial Area. We are having a kilogram of activated carbon at 25 shillings, Ugandan shillings. And another thing is we are using less or little concentration of activated carbon. We are using only 2% in the formulation. Reason being, activated carbon is so adsorbent, it has got a large surface area, and it has got its polarity. It facilitates the ethylene and also other organic solvents to be adsorbed into it. It is compatible with other paint ingredients. We are not seeing any reaction of activated carbon with calcium carbonate, with other emulsifiers, densifiers, preservatives, which we use in paint. White activated carbon is a substitute, can be used as a substitute for color pigment. We have been using titanium dioxide or titanium oxide as a color pigment. This agent, a very big color strength, that's why it can be used as a substitute for color. Another point is it absorbs moisture and other corrosive substances, so it can be a very good inhibitant for corrosion when we employ it in our paint. Little or no densifiers can be employed since the white activated carbon increases its viscosity in the paint. So if I have the formulation, I'm employing 20% of densifiers in my formulation, and I want to employ also white activated carbon, I reduce the densifiers to at least 10%, and then I also increase or I add the white activated carbon. So I'm cutting costs for the densifiers, but the quality will stay the same, it will remain the same. The viscosity will be okay. It is a good adsorbent to all solvents which are used in the formulation. For example, if I'm using ethylene, it will adsorb ethylene. If I'm using xylene, it will still adsorb that xylene. Any volatile organic component or compound, it is a very good adsorbent to it. If I say I'm using ethylene as a VOC in the paint formulation, I've tried to demonstrate a sketch equation for the adsorption, how it is. What activated carbon does, because of its large surface area, as I said, it just adsorbs the volatile organic compound to it. So this adsorption, the adsorbed ethylene, it will remain silent in the formulation, and so the paint can't release any pollutant. So that ethylene cannot be released to the environment. It's just adsorbed, and it will be within the formulation, within the paint. So we shall not be having any indoor air pollution. If we look at the reversibility of the reaction, can reaction be reversible under ambient conditions, that is the temperature and pressure? The reaction is irreversible. It will remain, paint will remain stable if kept at temperatures below 40 degrees Celsius, and also pressure of the environment, ambient pressure. Where do we apply the white activated carbon? It can be applied in paints for coating metals, paint which is used for coating metals. We can use the white activated carbon. When we are making the industrial grade paints, the epoxy, still we can employ the white activated carbon. When you are making automotive coating, paint or varnishes which are used for coating cars, vehicles, still we can employ the white activated carbon. It is best used in the exterior and interior wall paint, the white emulsion and latex paint, when we are using water and also solvents for dissolution of the other additives. So before the take-home insights, why this project is valid? Why can someone employ the white additive, the white activated carbon? Its cost, we have seen it is cheap. We are using little in the formulation. 2% is enough to adsorb all the solvents in the formulation. We don't require any machinery when you are using this white activated carbon, and it's available locally, so its sustainability is high. In Uganda, we have already got manufacturers of the activated carbon, so we can easily access the raw material. The product quality is compliant. When it is tested with paint, ready-made paint is tested, it has no effect on the quality of the paint. Looking at the toxicity of a white activated carbon, it has no effect to the human health. Actually, I saw it is having positive results to the human health, because activated carbon is also used in whitening teeth, employed in making toothpaste. So they employ it to the human health for betterment. Biodegradability, it is high, it is degradable, it is carbon. So it cannot persist in the environment. When we look at the test parameters for our already made paint, when we have used the WSC, which is the white activated carbon, we look at the drying time. Drying time, it is 15 minutes for the paint to dry. Color strength is okay because it has got a high color strength. As I explained, density, the density of the paint made using the white activated carbon, it is high, and even the formulation, it is reduced. It has no heavy metal, because heavy metals are tested in paints when we are doing quality control, so it does not provide that component of heavy metal. And the VOC is reduced in the paint which is used, which we have made using the WSC. So it stands for the validity of the project. That has been my presentation.
have the questions, the inquiries. Yes, Hano?
Thank you. Thank you for that presentation. And I apologize for two questions that you may have already addressed, but I maybe missed. So, of course, there has to be a liquid component to be able to apply the paint, right? So I guess I'm just wondering what that is. And my other question is around this white activated charcoal. Now, I'm only familiar with activated charcoal that is, black color because of the pyrolysis process. So how is this white activated charcoal made? Is there... Well,
Thank you, Hano. There have been not.
Yes, Bruno, thank you. Thank you very much for your presentation. Can you switch off the feedback? Yes, this white activated carbon is very interesting. But about availability, you said that is it available locally? Are you sure it is available processed here or it is imported here? And when it comes to color removal, I'm not an expert in paint manufacturing, but you said that it is good at removing color. Won't it affect the colored paint now? Is it possible to produce colored paint with this white activated carbon? Thank you.
Thank you. I have a similar question. What are the sources of this white activated carbon? Is it still from wood, from timber, or from somewhere else? And that naming, because we know carbon is black, but learning begins at conception and it stops at the graveyard. So we are still learning. So I'm quite curious because I knew carbon. When you say carbon, the blacker color, the blackness comes. Now this is white. I'm wondering the source. Otherwise, thank you very much for that presentation. And the issue of color, how are you going to address it? Thank you.
Thank you, Bruno. Now, you did make mention that the VOCs have, sweet smell and the associated advantages, which you did make mention. And then you talked about now the WSCs. Now, in the WSCs, do we maintain the sweet smell? Because for me, first of all, I like this. I like what you're saying, what you're proposing, because you paint a house, you enter in it overnight, and the next day the odor never goes away. And sometimes it's not even sweet, by the way. It depends. To be honest, I don't think that paint. I don't know about you people. I pretty much don't like it. Yeah. It doesn't, I don't like it. And in fact, I like this idea. If it can take away that odor, I would love that idea so much. Then the other direction is, at this moment, I'm trying to understand your innovation, because your recommendations were telling us to go that if you go to buy paint, look for paint labeled blah brand, it's available. So my question is, can you re-clarify to me what you're pitching? I need to understand your pitch. Thank you.
Thank you, Walakira. That was an interesting innovation. My question is this compatible in both systems? We are dealing only in solvent-based or even water-based. And then about the color they have talked about, I was also wondering whether it will have any effect on the colored paints that are not white. Whether, yeah, those ones that don't need maybe titanium dioxide, like what you said. And can you use it in varnishes? Those are clear coats now. Yeah, for now, maybe. Thank you.
Okay, thank you. Questions noted. I think I will start from the last question. Is it solvent-based or water-based?
One more. Does it remain, how it has no reaction, like does it react in the system, or it just remains there, as you say, you know?
So, start with the question of, is it solvent-based or water-based? First and foremost, the VOCs we are seeing they are volatile organic solvents. So I gave the reasons why they employ the solvents in the formulation of paint. Majorly, would have used water-based paints, and they exist on the market. But we employ these ethylene, these VOCs in the formulation for dissolutions and for other reasons which you have seen, reducing the drying time. My solution to the reducing or eliminating the VOCs is reducing the air pollution, the indoor air pollution. When we apply paint, having the VOCs, that smell, I think that is the pollutant which comes, or those fumes which we always hear after entering the room painted. That fume or that air which we breathe in, it is very toxic to the human health. In the long term, actually, if you sleep in the room, in the morning you feel headache, dizziness. So my project was aiming at how can I reduce or eliminate the fumes. So I brought in the white activated carbon. When I employ white activated carbon in the formulation and I paint the paint having that ingredient, I assure you it will not have the fumes. Instead, the white activated carbon will absorb the ethylene fumes. The reaction is irreversible, and white activated carbon doesn't react with any other ingredient. Ingredients such as we having ingredients like calcium carbonate, which we use in making paint, densifiers, we're having titanium oxide, does not react with any ingredient, any other ingredient, so it is stable. It only absorbs the volatile organic compounds. Employability in the formulation, I said I use only 2% in the formulation, which is so effective to absorb all the solvents in the formulations. Then let me go to that of color. Color, yes, activated carbon is black in color, but due to technology, we whitened this activated carbon to form white activated carbon. How? If we have the activated carbon, it is bleached using hydrogen peroxide. These manufacturers here in Uganda, they do it. They bleach it using hydrogen peroxide, and then they clean it using lime or warm water to make it clean, as in to wash away the other hydrogen peroxide, and then you remain with the white activated carbon. Then it is crushed, and we get something like chalk. Is it chalk in powder, white powder, chalk in nature? That's what they use in the formulation when they are making paint. Sources of SC, WSC, they get from sawdust. They get activated carbon from wood, the logs. They also get activated carbon from coconut shells and other wood metals. I mean, from other wood. Activated carbon is imported. Some of it is imported. And also, the company which I have said, Western Chemical, industrial area, it is also making it locally. It's a new innovation actually for them. They also started making it just recently. Then, when they are mixing the activated carbon, they use water in the formulation. They don't use solvents. When they are mixing activated carbon, they are using water in the formulation when they are making paint. Someone was asking, what do they use when they are mixing?
So it's only applicable in water-based paints?
Yes. I think I've answered everyone.
Our last participant, and that's Ejoku. So we are going to have Roy first, sorry. Let's have Roy as he prepares, because for him it's you have to use the cloud to access his presentation. Sorry about that. I think Sam, you can come now. Sorry for that. There was a technology hiccup. Hannah, are you able to see that presentation?
Yes, thank you.
Okay, that's good. So for the team here,
panel of judges, the participants, USPC officials around, and all the stakeholders, a very good afternoon. I'm Sam, and I'm going to present eliminating volatile organic compounds in paints. Problem statement. The volatile organic compounds that, as we've heard from previous speakers, they are a problem that has been there, but we all see gaps in providing the solutions. Yeah. Okay. Yeah. Okay, thank you. Volatile organic compounds contribute to air pollution and smog formation. They pose serious health risks, including respiratory and neurological issues. And then as well, industries right now are struggling with or to meet strict regulatory standards on VOCs. That is now by the compliance organizations that include ISO and NEMA nationally here, locally. Our statistics there stretch to show us that 17% of all those organic compounds, and of them, 17% of the volatile organic compounds are emitted into the atmosphere. And that is a big threat to the planet. My solution, or the solution we propose, to eliminate VOCs, we shall use UV curing technology to reduce emissions by an average of 80%. And also a new paint formulation that is compatible with the UV technology. Why do we think this is going to be a better solution as compared to the ones which are available? Our solution is going to be eco-friendly. As I've already stated in the previous slide, there will be 80% reduction in VOC emission. Superior performance in a way that is going to be very fast in curing. Whenever you paint, say, the wall, it usually takes about hours to dry. But when you use UV, it's going to be instant. It's going to be in seconds. You've already achieved drying time. Also, there's versatile application. You realize going to be in automotive, in furniture, packaging, electronics, and you will be adapting to specific customer needs. That is the technology behind the solution. We shall have photoinitiators in the formulation. We shall have oligomers and monomers, and then the additives as required by the customer. How does this work? We all see that our UV sample before curing, we have the oligomer, the photoinitiator, and the monomer at first very free. When you introduce in UV light, the photoinitiator is going to absorb that energy from the UV light, and then it will split into free radicals, releasing the energy that is going to initiate the polymerization. And after, we are going to see our keyword sample. We are going to see that both the oligomer, the monomer, and the photoinitiator are now intact. They are now joined together, forming a harder coat. Let's say if it was on the wall, it is, if you used UV light. Let's take that lamp to be our UV lamp. You've painted and you just throw, or rather flashlight on that, on the painted surface. It cures in seconds, or rather dries in seconds. The market opportunity. Industries manufacturing paints, Plascon, you are around here. There is also pressure from compliance organizations. The quality control analysts in the various industries producing paint, you always struggle to meet some of these standards. You realize that this is going to be, to reduce this pressure from these compliance organizations, UV curing is going to be a better solution for you. And we all see from that graph, sourced from Polaris market research analysis, we all see the demand, the growing demand for UV curing by 2030. That is a very good opportunity to get into the market. Our market size, nationally, we will start with about $5 to $10 million annually. Regionally, we can collect $160 million. And globally, it is so big that it will give us about $20.19 billion by 2031. Our competitive advantage, it's going to be an eco-friendly innovation as compared to the existing coatings right now. The point of versatility, I already explained that you can apply in various areas, that is automotive, packaging. We also have rapid curing over the traditional coatings that are available on market right now. My colleague talked about 15 minutes curing, that is still very long. If someone is painting, when you're having 15 minutes exposure to VOCs, that's already finishing you up. So this is very instant. And then also our advantage is that since most of the industries haven't borrowed this yet, there is an advantage of early entry to the market. And then also the cost efficiency. This is not going to take us a lot of resources to come up with this formulation and use of the UV. The business model. We shall get our money or other income through customized formulation from specific industries. I am glad Plascon is around again. And then also consultations and training for UV curing technology adoption. That won't be for free. And then also technology licensing. When Plascon wants to use my technology, I will license them to use my technology. I will say, I want this for a year, and they have to clear me up. So we go to how shall we enter the market? In phase one, we shall approach the furniture manufacturers. Who uses furniture without paint? I don't think there is any. Automotive refinishing, the vehicles, I don't think anyone has ever moved with a vehicle without paint. And then also the packaging industries. Phase two, that is now customer acquisition. There will be outreach to key industry players and trade associations. I'm glad the lady there is around. Phase four, distribution channels. Exhibitions or other demonstrations on UV curing. We shall be going to those exhibitions that have always been organized by Uganda Manufacturers Association to show people how efficient actually UV curing is good. And then also partnerships. We understand that you cannot have everything whenever you're doing manufacturing. Sometimes you get into memorandums of understanding. You partner with people who have them. especially for the UV lamps. For me, I will have the formulation, but I will partner with the UV manufacturing companies to supply me with the lamps that are compatible with my what? With my formulation. The impact, this impact will stretch to my SDG 13, that is climate action, to eliminate emissions. And then also, socially, I will have SDG 3 being seriously impacted directly, good health and well-being. Economically, industry and innovation, then infrastructure, SDG 9 is also directly impacted. So you realize that this technology is handling environmental, social, and economic aspects, and also helping the UN achieve their Sustainable Development Goals by 2030. Thank you very much for listening in. Sam.
Hano?
Yeah. Thank you for that presentation.
You are loud and clear?
Yes. You can hear me? You can hear me? Can you hear me?
Yes, now we can hear you.
Great. Thank you for that presentation. I have two questions. And they are, so I understand the UV curing makes it so that you need less solvent, maybe, but I guess I'm trying to better understand why you would need less solvent, because you would still need something liquid to apply the paint in the first place. And the other question is, you're now replacing solvent with something that can be UV cured. Can you speak at all about the toxicity maybe, or the other problems that these, so you're replacing one with the other, and I guess I'm asking, is the other less problematic than what you've replaced? Can you speak to that at all? Thank you.
Thank you. Can come again for the last question?
Oh, I was asking, if you replace some of the VOC, some of the solvents with something like a photoinitiator or a monomer, what type of information do you have about those new materials, right? So you're replacing a VOC because I'm assuming it's a toxicity problem. Are we sure that there is no toxicity problem with the materials that are being replaced? Did that come through?
Hannah, I think our internet is having an issue. I think I will kindly request you to text. Yeah.
Okay.
Thank you, Hannah.
Okay.
So let's have comments and inquiries from the panel here.
Thank you very much, Samuel. Firstly, I want to thank you for answering the question of show me the money. You've brought out that whether it's an estimate, right now no one is interested, but you are talking money. The 5 billion that Uganda can make from that's very important from the government perspective. And also how you are going to make the money, licensing, people consult. That is very good, and may you go and make it feasible. Now, question is, the UV, the equipment, are you importing it? How are you getting the equipment? Because remember again, on the government point, we hate importing. We would support something no matter how quirky, lack of a better word it is, if you're going to make it here. But if you say, go buy, take money outside Uganda, that would run and hide, then come later. So just to clarify how you get these equipment, that the UV, and then deal with the paint. Now, I want to understand, if you get this UV equipment, specifically it's only for the paints, or can I use it for any other purpose? For example, in additive manufacturing, or which most people call 3D printing, specifically stereolithography 3D printing, we do wash and cure, and it's UV lamp. After printing, you put your print into an enclosed UV system, then wait for some. Then, would you make that? Because I would, if you make it here, I would come and get it from here and market it and would sell. Yeah, because you're a businessman. Thank you.
Thank you very much, Samuel, for that interesting talk and bringing in a new dimension in the paint industry. I was wondering, are you ready to partner with us if you get the money? Because we are working on one of my projects with my students. We are designing some of these photo initiators. We have synthesized some of them. What's left is to put the fragments. It's very good. And I think we are also working on a review paper on some of these photo initiators, the pull and the push theory, and the solar cells. It will be bigger than the dyes. We shall also bring in the solar cells. It is a good project. Thank you very much.
Okay, thank you very much. I was wondering, I didn't really understand how your UV light will work. If you could summarize in a few words, if I have the paint like you described with the 3 tins, and I've just painted now, how will I use the V light, the versatility of the equipment, okay? Because if I understood it correctly, it's like you were saying after painting you apply V light and home and dry, isn't it? If I understood it correctly. I'm trying to look at the equipment, and I'm on 3rd floor. I'm painting there.
Yes, I think I'm in the same boat with my colleague. I was also wondering, at what stage do you employ this photo technology? Is it at the manufacturing stage? And if manufacturing stage, at what stage of the manufacturing? Because, as you know, this process generates radicals, which are very dangerous species. I don't know how we are going to control them to avoid causing another problem that comes from these rays from the UV. Thank you.
Before he answers that, our judge on via Zoom has 2 questions. How does the process reduce the need for Vox? That's number 1. And then the second one is, if you are replacing Vox with monomers and photoinitiators, what information do you have about the new materials introduced in the system? Are they less problematic than the Vox? Are there any toxicity concerns? So those are the questions that need to be addressed.
Thank you very much for those.
Yeah, well, thank you, Samuel. I'm a bit confused, but in the same way, they were asking, are you going to introduce these photo initiators in the paint? the oligomers, they are going to be in the paint, and maybe it's the same question they asked, at what stage? So are we going to buy them from you, or is, and then the, your UV light or equipment that is going to be used for drying, like it can cover what area? Like, I'm looking at it like it's going to take, imagine you're painting this whole building here and you keep on, I don't know really. You need to explain properly.
Thank you. Let me start with you, Madam Untali. The question was, am I going to introduce the initiators in the paint? The formulations which are right now in use do not have the photoinitiators. Mine is a new formulation that is compatible with the UV. Yes. And also about the equipment, I want us to bring it direct here. If this was the UV lamp, with light travels. Someone remind me the speed of light. I'm not remembering very well, but light travels so fast. You switch on a torch like this, does not reach there. So you just have to have a positioning of your lamp, directing it to the painted surface, and you turn it on, and in seconds, your painted surface will be dry. And then about what stage of manufacturing are we introducing in the UV? This UV formulation, the UV formulation is to be compatible with the UV. Now, at the industry, they will use the formulation. The UV will be used by the person applying the what? The paint. Because he is the one we are saving from the VOCs as well. Because usually, mostly it is this, when you look at the paint, the guys who are painting paint, who are applying paint, they are ever in protective equipment to prevent those emissions that come through during the painting. So it is to protect them. And also, our manufacturers, the formulation does not include, again, what is volatile to cause those irritations or other health issues. To Mr. Ivan, yes? You asked about if I'm ready for partnerships. Well, that is very exciting. It will even reduce the cost of importing some of these raw materials, because usually starting, you may not start with what you exactly need. So you having it would have saved the cost, and we shall also be encouraging, yes, our economy will be growing. We shall not take the foreign exchange again outside. So that will be something so interesting. And then you also asked to understand how the UV light works. I want to bring a very simple analogy. For those who do baking, some use the oven, some use the microwave. With an oven, you have to allow the cake to bake gradually. But for a microwave, the moment you put, because those are waves, the moment you put your cake, it will bake instantly. Are we together? An oven bakes slower than a microwave. For those who are familiar with microwave, yes, that is the nearest analogy I can transfer in here. And then, about the UV equipment, I would request us not to think of something so big. A UV, we said, we've all seen lamps. Lamps are very simple equipment that are so portable. I said would just, if this was my lamp, I've painted that surface, I just turn on the lamp until, even if you're painting a very tall building, by the time you're able to access to paint that place, meaning you can still take the lamp there and direct your light that side. Thank you. And then he asked about if he does something to do with. Mr. Moses, remind me, you were saying something about my pronoun or something?
Now, any other applications of your UV lamp can it be used anywhere in 3D printing, drying and curing? Can it, now, what you're saying is bring other concerns. In this, how safe is this UV to you who's using it to dry the painted buildings? How safe? Because it is UV.
Yes.
Are we safe using it? Because we are saying light is traveling all over the place, 300,000 kilometers per second, and I'm there and I'm using it. Am I safe?
Actually, thank you so much, Mr. Moses. Actually, we could as well use just this sunlight, by the way. But because we are, when you're painting, sometimes you're in an enclosed area where you cannot access direct sunlight. And remember that even silent has UV. So if we are scared of UV, then we should also stop moving under the sunlight. I'm not just being, I'm only trying to bring it that the UV is not as dangerous as we may think. Yeah. Then also on other uses, since it's, it can be used elsewhere. Not only, it can be in paints, so long as it involves, so long as the UV is compatible with our formulation. Actually, in that case, you would have brought again business. Thank you so much.
What he was trying to point out is that UV is dangerous. Yeah, it's dangerous depending on which wavelength. So maybe you could go ahead and characterize the wavelength of this UV equipment you're dealing with. Yeah, there's the A, B, C. I don't know the wavelength exactly. What he was trying to say is safety comes first. Yeah, and in my presentation in the morning, I told you hazards can be physical, like radiations. That's how you see these people developing cancers from nowhere. So my chance, your equipment is just so very good that I'm also now confused, yeah? But you need to still go ahead and characterize the kind of wavelength you're going to be dealing with. That's why this ozone layer is in place. Yeah? Because some of that UV rays that will do, in a way, be dangerous to us, is kept up there. So that's what he was trying to ask. Maybe you could go ahead and just characterize. Maybe it was not a question. I was trying to clarify and maybe understand better. Thank you so much.
Okay.
So if you feel like you need some coffee to have more caffeine in your blood, you can caffeine up so that you be strong enough for the last 15 minutes. Is our presenter ready? She has moved out.
Yeah. So then to try to give about the highlight of what's going to happen tomorrow. So tomorrow at 9, we'll be starting. That will be day 2. And we'll not have more discussions after this presentation. We'll let you go, rest. We'll be starting after 9. Then we'll have the announcement of the winners. So after the tallying from the jury, those results will be declared tomorrow. So those who have presented, please be around. We'll have, besides the handover, we'll have the awareness of which this is an eye-opener, or an eye-opener, or showing us what will happen. That time it will not be only, it will be told, don't miss YouTube. So all this has been, all along it has been streamed. All along it has been streamed online and it was live.
Thank you so much. My name is Nalgo Roy from Makerere University, a student pursuing Bachelor's of Science in Industrial Chemistry. So, as the problem statement already stated by my colleagues, I'll add on by elaborating more. So, what are some of the challenges of using volatile organic solvents? First and foremost, we know that they pollute the air. Yeah, we know that those organic volatile solvents or compounds, they can easily react with what? With oxygen to form ozone that is dangerous to our environment. So there is also some health risks. Indoor air quality, as already mentioned by my colleague. So what is my solution? My solution is using a coupled technique of adsorption, cryogenic condensation with photocatalytic oxidation. Methods have been developed by the previous researchers, whereby one of my colleagues talked about the adsorption process of using activated carbon. Then also the cryogenic condensation method had ever been researched about, and that involves cooling gaseous compounds into liquid form. So how does it work? Firstly, this applies to after the process of manufacturing the paint. Because we know how are these volatile organic solvents and inorganic solvents come about to affect the environment. During application, for example, we know that those solvents are already what? Volatile. So after formulation, and coming up with our paint, they are volatile. And that's how they go into the what? The environment. So this solution applies to after the formulation of the what? Of the paint, at the stage of packaging. So we know that during the stage of packaging, those compounds are what? Are being volatile and they are escaping into the environment. So onto that, we shall add a unit of adsorption, another unit of cryogenic condensation, and then the polycatalytic oxidation unit. So how do they work? The adsorption technique uses activated carbon, and this activated carbon will do what? Adsorb the solvents from the gaseous mixture or the air that is released, that volatile solvents that are escaping. It will adsorb the solvents onto carbon. And this carbon will be later thermoheated, which enables it to release the what? The volatile solvents. After releasing them, they will go to that unit of the cryogenic condensation. This involves cooling down, condensing those solvents into liquid form. And at this stage, we can easily recover the what? The solvents that had been used. So it is 2 in 1. We can easily recover the solvents that had been used, and that makes it cost effective. Then, in case you don't want to recover them, you take them to the photocatalytic oxidation unit. This is divided into 2. It is divided into the electrostatic precipitation unit and also the ozonation unit. In the electrostatic precipitation unit, those escaped solvents, volatile solvents, can be removed, whereby they are attracted. You use an electric field which attracts them, and then you release the cleaner air down. So that's it. Then we shall go to value proposition. It is highly efficient. It is a combined technique that combines 3 methods. And through combining it, it improves the efficiency of all the methods. For example, that photocatalytic oxidation unit, it can easily break down the what? The solvent into less harmful ones, or into fuels that can even be used somewhere else. Then it is also cost effective in 2 ways. Firstly, you can easily recover the what? The solvents that you had used. And also, it reduces the cost, because from literature, if you use the cryogenic condensation technique only, it is quite expensive, and it is effective for high concentrations of volatile solvents. Those are some of the value propositions. It is environmentally friendly because it is eliminating the harmful gases. So I had already perused through that. That is the technology overview, which is divided into 3 steps. The first one, I talked about the adsorbent. We can use carbon oxalates. Then the second step, it is the cryogenic condensation, which involves cooling those solvents, hence recovering them. Then lastly, the photocatalytic oxidation, which involves passing the condensed pollutants through a photocatalyst, such as titanium oxide or zinc oxide, hence breaking down the solvents into less harmful ones. Opportunities for this technique. So, as I already said, these techniques, the 3 techniques have been invented previously from literature. For example, we have where I reviewed from, we have the Shai and Hag, that is 2014. So, they already apply them in the water treatment. That means this same technique, you can apply it in water treatment. Then we have water purification, food and beverage industry, pharmaceutical industry, and energy industry. So what are the competitive advantages of this technique? We have high efficiency. Since this method removes both the organic and the inorganic volatile compounds. Yeah, because activated carbon has that higher affinity for the non-polar volatile organic compounds. And then the photocatalytic oxidation method has that higher affinity for the polar organic compounds. Crowdfunding. And also crowdfunding. Sorry for that. So go-to-market strategy, that is selling directly to companies. We've seen that it has a large application. Impact. The impact it has on the environment is it reduces the pollutants that are released into the environment. The health risks. I personally am allergic to that scent that comes from paint. Then energy saving and also economic impact. Thank you so much.
I would request Hanno if you have any comment.
Can you hear me, or would you prefer that I write them out? I'm trying that again. Do you hear me, or should I just write them?
We are hearing you.
Okay.
Repeat just now we're okay.
Okay, good. Otherwise, let me know. I can also type. So I'm wondering about how you would apply this technique. So if you say you want to capture the gas and then do other things to it, I'm thinking about painting, I don't know, maybe a house. It would seem hard to capture any gas there. So I guess this could only be applied for specific things. Let's say painting like wood or material.
Uganda shillings now, given what you're talking, what would you do? You may not even give an answer. I want you to think about it. Because most of you, if
why they are being added in the paint. You know, for flow, for, you know, yeah. So that paint might not flow because I don't know how much you are going to remove by applying the activated carbon. And then you're saying it's at the packaging stage. Is it before it goes in the packaging, like in the tins or buckets, it is passing through that unit? Oh, it's, okay. So maybe you can give us light on that.
Okay, thank you so much. So I'm going to go to applicability because most of the questions were reiterating around that. Okay, so applicability, it's like this, before packaging, and then the solvents that I'm not removing directly the solvents, because remember, after formulating, they are volatile, they start escaping. So I'm looking at those gaseous mixture that escape, the ones that go to the other unit. It can also be applied to display booths whilst playing, for example, in the automotive industry, the same technique. I think that's it.
So the House is going to decide on this. There is a sister of this lady here. She has been online since the afternoon session. She had an exam and tried to present in the first batch. So she couldn't present because she was in a paper. Then she came on. When we tried, then she told me power went. But now she has been on, she wanted to present. So dear jury, can you give her your time? Oh, okay. Bagonza Joy, 10 minutes strictly. It's your time.
All right. All right. Thank you.
Pardon? No, she's on leather. Yeah, another Joy.
Yes, thank you very much.
Yeah, we are seeing your
The
presentation.
jury. All right. The jury, ladies and gentlemen, a good evening. My apologies for the technical problem that occurred earlier. I am Bagonza Joy Margaret, a medical student at Equator University. I'm in year 1. I'm going to talk about the innovative solutions for effective reuse of lime leather pelt trimmings in my abstract. Well, beginning with the problem statement, I'll give a brief history about leather. It began 40,000 years ago in Hoxton, England, and throughout history, cultures worldwide have found it valuable, and there have been different products being made from leather, the shoes, the bowls, different crafts, and I'm sure you all know about the different items that are being made from leather. So in tanneries, during the process of converting the skin and hides to leather, there has been a generous amount of solid waste that has been observed, and specifically that is the pelt leather trimmings, which is unavoidable waste generated. It has caused environmental concerns since it ends up in landfills, polluting the environment, and groundwaters near tanneries have been found to have elevated levels of toxic substances that are a health threat to the people. There has been reuse of the solid waste of leather pelt trimmings for producing collagen hydrolysate, which can be used for returning but there is still a reasonable amount of this waste observed that calls for a sustainable innovative action to utilize the lime leather pelt trimmings, and I thought about 2 solutions, and among them would be possibly incorporating the reuse of solid waste of the lime leather pelt trimmings in tanneries by the processing industries into fertilizers to boost on the quality and quantity of agricultural produce, as well as into fish feeds. Why my mind drew to these 2 solutions was to create something that will deal with providing one of the basic needs of man, which is food, to the highly growing population. So when we look at the value proposition, proper management of lime leather pelt trimmings through innovative solutions will help to protect the environment through reducing the pollution that ends up in the environment, as I talked about it earlier. It will also improve on food security for the growing population. This as well is cost efficient in fertilizer manufacturing and fish feed processing. So when you look at the technology overview that we can use, first we are going to delime the leather pelt trimmings. Well, since we are trying to find the innovative solutions of converting the lime leather pelt trimmings into something else, well, we have to first deal with deliming. Why? When we have lime pelt leather trimmings, they do not easily decompose, of which we want to make fertilizers. That means we have to get something that can decompose. So first, we are going to carry out defatting using organic solvents to improve on the quality of the product by reducing on the odor. We're also going to cater for our consumer by hydrolyzing into smaller peptides or amino acids to make it digestible for the fish. And secondly, we are going to compost the lime leather pelt trimmings that we've delimed by mixing it with organic materials like plant residues. We're going to pelletize for granule fertilizers or hydrolyze to obtain liquid fertilizer. And the market opportunity that I have is based on the trends in sustainable farming alongside rising interest in sustainable and organic agriculture, and also soil conditioning advantage, since lime leather pelt trimming fertilizer product help neutralize acidic soils and is cost efficient. So the competitive advantages with converting this waste into fish feed or fertilizer, it is cost effective since it utilizes an abundant and inexpensive industrial product. So we'll not have to put in a lot in the maybe purchasing of the raw material because it's already there in abundance. So it has a rich nutritional content to the fish since it supports growth of species with high energy content, and fish being one of them. So sustainability and eco-friendly as it reduces on fish meal, mitigating the environmental impact of overfishing for traditional feed sources. So when I try to look at the key results, proper management of these lime leather pelt trimmings through innovative solutions that I've talked about, of converting it into fish feed and fertilizer, will reduce the pollution that ends up in the environment alongside the diverse impacts on the human race health directly or indirectly. So the keywords in my abstract are innovative, liming, and the pelt trimmings. So my abstract on innovative solutions for converting the lime leather pelt trimmings into sustainable fertilizers, fish feed, provides a cost-effective solution for waste management and also reduce environmental harm. This also establishes a sustainable framework for leveraging industrial byproducts aligning with the global sustainable goals. Thank you so much for your time. Back to you, the jury.
Hano?
Yes, hello?
Hano, any inquiries?
Let me type them out in the chat, okay?
Okay, thank you. So our jury here, from that presentation.
Yes, Roy. Thank you very much for the presentation. I think as a person from the medical background, you are aware of the health effects of some of the pollutants in the ternary production, especially the metals, chromium and associated heavy metals. In your production of fertilizers, it's not clear how you are going to eliminate them before you produce the fertilizers. It may happen that as you try to improve food security, you might compromise food safety. That aspect is not clear. Thank you.
Thank you. The analysis was good, but technically I didn't see the other side of how you are really going to take it out. How are you going to do it, apart from what you have talked about, practically?
Maybe mine is on the issue of this fertilizer. How do you take care of anything that you suspect that is missing within the raw materials? How do you enrich it? It is also not coming out. Thank you.
Thank you, Joy. You understand it's good to have a solution to a problem, but I want you to throw more light on, if you look at the existing fish feeds, for example, and fertilizers, and from where they are made. They're not made from the ternary waste. I want you to clarify on how the ones you're getting from the ternary waste have a clear advantage, apart from, because what you're giving is actually not the advantage of the fertilizer vis-a-vis other fertilizers, but rather the advantage of the process. So I want you to throw more light on how or why someone who's using fertilizers from other sources or fish feeds, which can also be made from other natural materials, should leave them and get the fish feeds or fertilizers you're getting from these ternary wastes.
Joy, please, can you answer those questions?
All right. Thank you so much. Well, I was carrying out some research from the articles that I read. I basically, based on leaving aside the other wastes like chromium that are got from tanneries, but I focused basically on the leather pale trimmings, and that's why, but I'm going to throw more thinking towards how we can still deal with the other waste like chromium. Though I thought of one of the waste that I would have while converting it into fertilizers as the aluminium salts. So I'm going to have these aluminium salts also being maybe incorporated into something else like processing of the anti-inflammatory drugs. That's the waste that I had looked on, but for the chromium, I'm going to think about it and make some more research. So how maybe the fertilizer is going to be made? It's going to be mixed together with the other organic materials like the other residues, plant residues, in order to supply the other missing nutrients from these pale trimmings. Then the advantage over it from other feeds or other fertilizers that are being made. Well, for other fertilizers, there are very many of them on market that are inorganic in that after using them, yes, you're going to have these good yielding plants, but then there are going to be more negative effects imposed on the soil. For example, the soil acidity may increase. There are going to be changes in soil pH, whereas if you use the fertilizers that are being made from the lime pale leather trimmings, for them they are going to just neutralize the soil and maybe the other effects that have been caused by the other fertilizers. Then for using it as a fish feed than other fish feeds, well, we are having a raw material that is available and in abundance. So we are not going to go through putting a lot of money into purchasing the raw material. We already have the raw material in abundance. Yeah, that's how it's going to be of a clear advantage than the other sources of the fish feeds. Yeah, basically that. Thank you.
Thank you very much for your patience and effort. And yes? She responded.
There is questions that Hannah posted, and sorry, the mind was getting tired. Alongside the questions prior, what about the materials in the trimmings? Will they harm the fish and then the people who eat the fish? And that's more about
okay.
And this is mainly about what we have, whereby we may see as the animals will eat this and it may end with them, but in the long run will eat the animals, and that will be bioaccumulation along the food chain. So I think that question, I don't know whether Bagonza is still on to address it.
Yes, I'm still on. Well, I want to address.
Yes.
Well, the components in the trimmings will not harm the fish or the people. One of the components, you're having collagen, nitrogen, and minerals. So collagen is also useful in our bodies. So when it's being ingested by the fish, in turn, it will also benefit us if we eat the fish. It's a component that helps in the recovery of wounds. Let's say you get a wound, it helps in bone formation, so there will be no effect to the human being that may be going to consume the fish, and there will be no harm to the fish itself, as a fish requires high energy for it to, in its process of growth, and that energy is going to be supplied by the collagen that's in the chilies. Yes, thank you.
Thank you so much, Bagonza Joy. And I would like to extend my gratitude to you people here who have made this day colorful. We are going to have a comment from the jury and just an overview of what has happened, what's their feeling about this, and their comments, maybe advice to us who are here, and how to take this on from, because they are encouraging us not to leave it here, but also to see that these solutions are out in the world. So thank you, and after them, I will give the microphone to Edson, who will close the event.
Yes, good evening, ladies and gentlemen. I would like to take this opportunity to thank you for the very innovative ideas that you've presented to the team. I believe you've given the team a very big task on how to evaluate the best, but eventually there should be a best. And but I wish you the best. My simple advice is that as you prevent such innovations, don't be too academic. Of course, you can include in the academic aspect, but the people out here in the field just know the language of money. Indicate to them how cost-effective your idea will be, how it will save this country, and maybe how many people are likely to be employed. Otherwise, I would like to thank you for the good ideas. You've not clapped for me.
No, for the interest of time, I'm very certain his presentation cuts across. And I don't think we need to add more, but similarly to thank you all for having taken time to write what you have written and to present similarly. The results will be there. And when you're not picked on as among the best, continue refining your ideas. One time, one day, it will be done. Thank you.
Dear participants, your participation is not taken for granted. You took your time, you organized, you sat down in teams, you had sleepless nights to organize this piece of work. Of course, at the end of it, in a particular theme, they choose maybe one or two and so on. But when you fail at this level, don't throw away your project, just like the previous speaker. I enjoy reading the history of science. When you read the history of science, you get inspired. When you read about Nobel, you know Nobel? You've heard of Nobel Prizes. But when you read about him, you see how determined he was. You can imagine someone sitting in a lab and is seated on a stool with one leg. He had a one-legged stool. Some books even put his picture seated on a one-legged what? And you know the importance is monitoring a reaction 24/7. When he dozes, he wakes up. When he dozes, he falls dead. When you read about the history of the Wright brothers, you read about the Wright brothers? You know how many times they flew those flying objects and they were not succeeding? And you can't imagine now a plane can fly for over 11 hours without refueling. So wherever we are in technology has come a long way. And it begins with a dream, with an ambition. Thank you very much.
I want to thank you once again. I think I've been giving you my comments. Take them serious, and I wish you success.
Thank you, participants. Thank you for your efforts. All the innovations were coming from very brilliant ideas. They were all good. Keep it up, don't lose hope. There will be a winner, yes, but keep researching. Just as my colleagues said, it's not the end. Where you have started, it's good. Keep it up. Congratulations for reaching this far. And thank you all.
Hano, your concluding remarks or a word of encouragement?
I don't know if you can hear me well. Can you hear me?
Yes, we can.
Okay, so I also just wrote it in the chat, but I just want to congratulate, the whole UCPC team for putting this together, but also all participants for spending time and thinking about these types of solutions. And so just congratulations to everyone, and it's been a pleasure being here.
Thank you so much. Thank you so much, and we're also delighted to have you here.
Certainly.
And I think with that, we officially close this day and give room for ourselves to rest, re-energize, see ourselves tomorrow. And may you have journey mercies as you go back. In Jesus' name I've prayed. Have a nice time, Hano.
See you later. Thank you.